Hey guys, tonight we're heading somewhere cold. Not just refrigerator cold, but you could freeze your eyelids cold. Mars. Specifically the southern ice cap, where the robotic probe network called 3AA Atlas has just picked up something that shouldn't exist, a pulse. Not a heartbeat exactly, but a steady repeating vibration echoing beneath the ice, like the planet itself forgot it was supposed to be dead. Picture it endless white plains dusted red by iron oxide, the faint hum of solar-powered instruments ticking away in a storm that never quite ends. You're hovering above the polar dome reading data through a calm blue interface, watching a line on a graph flick up, then down, then up again. Perfectly rhythmic. And yes, you probably wouldn't survive this. The temperature here can drop below 130 degrees, where even carbon dioxide turns solid. Your breath would freeze into glittering dust long before you had time to panic. So before you get comfortable, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here. And while you're at it, post your location and local time down below. I love seeing where in the world or galaxy you're listening from. Now dim the lights, maybe turn on a fan for that soft background hum, and let's ease into tonight's journey together. The first pulse came through at 0317 UTC, quiet clean, and so perfectly timed that the system initially flagged it as a calibration error. But 3i Atlas is thorough. It checked again and again, and after the sixth identical signal, even the skeptics began leaning forward in their chairs. You drift over the Martian cap, the whiteness stretching like a frozen ocean. Below 2 miles of layered ice conceal salt pockets, ancient dust, and something else. A thin film of liquid brine that radar can't quite explain. Scientists still argue whether it's truly water or a conductive sludge kept warm by buried minerals. Either way, when 3i Atlas's radar beam hits it, the reflection wobbles. A heartbeat in stone. It's oddly poetic, a planet once drenched in rivers, now sighing under ice. You imagine Mars remembering itself one pulse at a time. Maybe it's geological, a relaxation of crustal stress left from ancient impacts. Or maybe, and here's the part that keeps geophysicists awake at 3 a.m., something down there is moving. One fringe group claims it could be thermochemical convection, basically chemical reactions generating tiny bursts of heat that rise like bubbles through a soda bottle. Another less fringe, but more caffeinated, suggests electromagnetic coupling between the core and crust. Mars still twitching to its own magnetic rhythm even after its dynamo died billions of years ago. The mainstream fact is simple enough. Radar soundings from ESA's Mars Express mission already hinted at subglacial reflections back in 2018, much like Earth's hidden Antarctic lakes. The new twist is Motion 3A Atlas's instruments caught a periodic shift every 87 seconds. Too fast for tectonics, too slow for machinery. Something in between. You picture the scientists at the control room in Arizona, faces lit by monitor glow, their coffee cups orbiting stacks of printouts. Someone jokes that Mars is learning Morse code. Someone else swears they hear a pattern forming in the static like breathing through a wall. Outside, the desert night mirrors the Martian one thin air. Cold stars silence so deep it hums in your ears. You realize that across millions of kilometers, both worlds are vibrating however faintly. Earth's microseisms, Mars' frozen thrum, two rocky hearts beating in the same cosmic room. It's easy to romanticize and honestly a little comforting. After all, the universe rarely moves in straight lines. It wobbles, forgets, restarts. Maybe that's what 3i Atlas found, not life, not aliens, just persistence. A reminder that even when everything seems still, the universe keeps tapping its foot to some ancient rhythm. And as you float above the ice, that rhythm begins to feel contagious. You catch yourself breathing in sync with the planet's pulse in 2-3, out 2-3, until the red horizon starts to blur at the edges. The data continues to flow gentle as snowfall. Beneath it all, Mars hums. You glide lower into the red hush of a Martian dawn. The thin sunlight spills over the southern ice cap, turning every ridge into a blade of gold. The air is so light it barely exists. Dust floats like lazy snowflakes. You can almost hear the silence. And then faintly there it is again. The pulse. It comes through the 3i Atlas network as a series of faint electromagnetic blips. The system translates them into a visual waveform, and you watch it rise and fall like the slow breathing of an ancient animal. Somewhere beneath the kilometers of frost, the planet's crust flexes. The rhythm is hypnotic, almost human. You picture the surface beneath you, a place that's both solid and fragile. The top layer is frozen carbon dioxide, seasonal and ever-changing. Beneath that lies water ice ancient as the first bacteria on Earth. Some of those layers record entire epochs, volcanic winters, dust storms, comet impacts. Each one a page in Mars's diary. You float above it, eavesdropping on a frozen confession. The funny thing is, this isn't the first time Mars has surprised us. Back in 1976, the Viking landers ran experiments looking for life in the soil. They found chemical reactions that looked a lot like metabolism, tiny oxygen bursts when nutrients were added. Scientists still argue whether that meant microbes or mere chemistry. The debate has lasted almost 50 years, outliving most of the people who started it. And now, here's 3i Atlas, listening to the planet's pulse and reviving the same question in a new disguise. Is Mars alive, or just pretending really well? As you float past the rim of a massive crater, Argyre Planitia, the sunlight glints off frozen dust devils looping lazily like red ribbons. Down below, the echoes from 3E Atlas reveal something curious. The pulse grows stronger near fault lines where the crust fractured eons ago. Could it be geothermal activity still lingering deep underground, or magnetic resonance, a planetary aftershock that refuses to fade? The scientific camp splits neatly into two. The thermal crowd argues that remnants of volcanic heat are melting small pockets of salt water, creating convective ripples under the ice. The magnetic romantics believe it's the ghost of Mars' lost magnetosphere, still echoing faintly like the ring of a struck bell. Both sides have coffee. Neither has sleep. You can almost imagine the scientists muttering under their breath, just one more dataset, like gamblers whispering before the next card. One of them jokes that if they can't explain it, they'll just say, "Quantum frost." It gets a tired laugh, always a good sign in science. Down below the surface gleams. If you were really standing here, your boots would crunch over frozen CO2, each step releasing a puff of white fog. The horizon curves gently. Mars is smaller than Earth, so you can feel the planet's roundness more sharply. It feels intimate, almost cozy, like walking on a snow globe. The pulse continues steady, reassuring and possibly regular. Every 87 seconds, click, click, click. You wonder what it would sound like if you could actually hear it. Maybe like a heartbeat muffled through miles of ice. Maybe like the ticking of an old wall clock in an empty house. There's a strange comfort in that rhythm, a reminder that even frozen worlds still move, still breathe in their own quiet ways. A historical fact drifts into your thoughts. In the 19th century, astronomers like Giovanni Schiaparelli thought they saw straight lines across Mars Canale. They imagined civilizations digging massive waterways through the desert. The myth stuck around for decades, inspiring novels. Panic even done radio plays about invasions. Humans have always wanted Mars to be alive. We just didn't expect it to sound like this, like the world itself, humming lullabies through rock. Scientists still argue whether the sound's harmonic overtones, tiny variations detected by 3i Atlas, are caused by interference or internal resonance. But deep down, no one wants to explain it away too quickly. Mysteries, after all, are better company than conclusions. You lean back, floating just above the ice plain. The faint hum vibrates through your bones, or maybe through your imagination. You're not sure where one ends and the other begins. Somewhere far below, the pulse quickens slightly. You don't know why, but you feel like Mars just noticed you listening. And then the sound fades again into stillness, leaving only wind over dust and the soft sigh of a planet that hasn't finished telling its story. The hum lingers in your ears long after it stops, like the echo of a dream you can't quite wake from. You hover above the red desert, wondering how a lifeless world can make you feel so observed. Back in the 3i Atlas command room, the data feed keeps pulsing a faint rhythm regular as the ticking of a clock inside a glacier. Analysts tilt their heads at the waveform on the screen. The peaks look too precise, too deliberate. Could be instrument interference, one murmurs. Could be Mars, another replies, half joking, half hoping. You watch the signal scroll across the monitor. Every 87 seconds, every single one a heartbeat that refuses to stop. No one says it aloud, but the question hangs in the air. What if it's not just physics? The next morning, if you can call a Martian sunrise morning, you find yourself gliding above a canyon rim near the pole. The sunlight bleeds across the ice in soft peach tones like watercolor on cold glass. There's no sound, only the occasional whisper of dust skimming the surface. 3i Atlas continues scanning. Its radar beam pierces the crust, bouncing through layers of ancient ice like sonar through a frozen ocean. Each reflection carries a slight delay, and from those delays computers reconstruct a picture of what lies below. At about 2 kilometers deep, they find something unexpected: movement. Not much micrometers maybe, but movement nonetheless. Scientists still argue whether it's caused by shifting brine pockets or oscillations in the magnetic crust. Either way, it matches the pulse. You remember that magnetic fields once danced here billions of years ago. Before Mars lost its molten heart, its dynamo spun like Earth's shielding it from solar radiation. When the field died, the atmosphere was stripped away molecule by molecule, leaving the planet exposed to the sun's breath. That's the mainstream fact: magnetic death equals planetary silence. But now somehow that silence is humming again. Somewhere deep beneath your feet, iron-rich rock might still hold residual magnetism, tiny atomic compasses twitching in unison. When the planet flexes from temperature change, those particles shift ever so slightly, creating microcurrents, enough to fool sensitive instruments into hearing a rhythm, or depending on who you ask, enough to become one. A quirky detail surfaces from an old logbook during the InSight mission in 2021. The seismometer recorded faint vibrations, so faint they were thought to be static. But after filtering out the wind noise, one pattern kept repeating, roughly matching the new 3-iodid Atlas pulse. Back then, the team dismissed it. Now it looks prophetic. You imagine the scientists scrolling through their old data, eyes widening as they realize they might have been listening to the same beat years ago. It's like finding out the house you grew up in was whispering to you the whole time, you just never listened properly. Outside, a dust devil spins lazily, twisting through the pale air like a living thread. Its static charge pops faintly, creating little blue sparks along its rim. Mars, despite everything, still finds ways to move. You lower your perspective, tracing the outlines of buried craters, their rims softened by centuries of frozen wind. They look like fingertips pressing against glass from the other side. You wonder half seriously whether the planet's crust might be flexing like muscle, too slow to see but steady enough to measure. That thought leads to another. The rhythm source could be thermal convection gases trapped in ancient lava tubes, expanding and contracting with the planetary day. Or maybe the brine beneath the ice acts as a conductor, pulsing with weak electric discharges. Scientists still argue whether such discharges could mimic biological patterns, what they jokingly call false life. A young researcher nicknames the signal Martia. It's not official, but the name sticks. Soon every conversation at the lab starts with, "How's Martia doing today?" Someone notices that the frequency shifts slightly during solar storms, as though the planet itself is flinching. Another notices it responds faintly to temperature changes at the polar dusk. She's moody one jokes, and they all laugh, because the alternative that they're anthropomorphizing a dead planet isn't something they want to admit. Outside your window, a faint aurora glows at the horizon. Yes, Mars still has auroras. Without a global magnetic field, they flicker locally above patches of crust that cling to remnant magnetism. They shimmer like shy ghosts. The pulse beats in sync with one of those flickers tonight. Coincidence, maybe. Or maybe Mars is remembering how to shine. You exhale slowly, your breath turning white against the thin air. The hum is still there, patient, ancient, indifferent to explanation. Maybe it's not trying to tell us anything. Maybe it just is. Above the icy plains, the red planet keeps breathing in its slow, secret rhythm. And you, listening from a world away, can't help but breathe along. You drift closer to the pole, the air thinning, until silence becomes a texture. Everything feels muffled, even your thoughts. The horizon fades into white, then vanishes entirely. It's not emptiness, it's just Mars taking a long, quiet breath. Beneath your feet, the ice isn't uniform. Radar scans from 3i Atlas show alternating bands of water and dust like tree rings stretching back millions of years. Each layer tells a story of climate shifts. When Mars tilted more steeply on its axis, sunlight reached the poles, melting ice into slush. When it straightened again, the cold returned, trapping that moment beneath the new frozen skin. And somewhere deep in those rings, the pulse lives. It feels strange, doesn't it? To imagine a planet's memory encoded not in fossils or ruins, but in vibrations. Scientists still argue whether the signal might be a natural resonance from ice cracking under stress. Yet the pattern repeats too consistently, like a song that forgot its words but remembers the tune. You close your eyes, or at least imagine you do, and picture that underground ocean, because that's what it might be, an ocean. Back in 2018, the European Space Agency's Mars Express radar experiment found evidence of a 20-kilometre-wide lake buried under the South Polar ice. Briny dark, probably the consistency of thick syrup. For years it was considered controversial. Half the community called it groundbreaking, the other half called it noise. But 3i Atlas has now picked up echoes that suggest that Lake might not be alone. The data shows faint reverberations like ripples spreading from multiple sources. If those are smaller brine pockets, they could be interconnected tiny arteries feeding into a hidden system, a planet-sized circulatory network. The idea makes you smile. Mars, the desiccated corpse, still has blood, just thicker, saltier, slower. You imagine it pulsing faintly once every 87 seconds, the rhythm of temperature gradients and mineral exchanges. The salt keeps the water from freezing, allowing microscopic convection. And if there's even trace warmth, maybe from radioactive decay in the crust, those brines could still flow just enough to keep the planet's heart beating. There's something comforting about that. Life, or at least its stubborn cousins, tends to cling to motion. On Earth, extremophile bacteria live in boiling vents, radioactive waste, even Antarctic ice. Why not Mars? If there's salt and water, there's potential. Of course, scientists still argue whether those conditions are habitable or just interesting. Science is cautious that way, like a cat inspecting a mirror. The hum beneath your feet vibrates a little louder, as though agreeing. A small team at the University of Bologna has been analysing the 3i Atlas data using acoustic modelling. They've noted something peculiar: the rhythm isn't perfectly constant. It speeds up when the sun's rays hit the ice cap at a low angle, then slows again during night. It's as if the planet's heartbeat syncs with dawn. Coincidence, maybe. Or maybe that's just what worlds do: they breathe in light and exhale darkness. You remember a curious historical footnote: early 20th century astronomers used to sketch Mars by hand through telescopes, often exaggerating contrasts. They saw waves of darkening across the surface during spring and thought vegetation was blooming. They called them seasonal waves. Decades later, we learned it was dust movement. But the poetic idea never really died. Mars has its moods. Down here, where the radar maps the ice like sonar through a frozen dream, the mood feels ancient and deliberate. You picture that buried ocean as a living memory, one that never forgot the warmth of sunlight. The 3i Atlas sensors adjust automatically to compensate for temperature gradients. You glance at the display, microfluctuations ripple across the graph, almost imperceptible. The system labels them thermal breathing. That's what the engineers called it. You smile. Even the machines have started using poetic language. A sudden vibration trembles through the data feed. Not much, just a half-second delay, but noticeable. The waveform sharpens. The pulse doubles once, like a skipped heartbeat, then returns to normal. A reminder that even the simplest rhythms can surprise you. Outside, the red twilight deepens. Shadows of ridges stretch like slow-moving fingers. You realize you've been listening for so long that the silence now feels louder than the pulse itself. You take a deep breath, mirroring the rhythm. In, 2, 3, out, 2, 3. The hum steadies. Your heartbeat matches Mars, or maybe it's the other way around. And as you hover there, suspended between ice and starlight, you can't help but think maybe what 3i Atlas found isn't a heartbeat at all. Maybe it's an echo. A memory of warmth still trying to return home. You float lower still until the white glare of the ice softens into muted amber. Below you lies a landscape few human eyes have ever seen: rippled plains of frozen carbon dioxide and ancient dust stretching endlessly toward the southern pole. It feels both vast and claustrophobic, like being inside a snow globe that forgot to stop spinning. The 3i Atlas sensors hum faintly in the background. Their data flickers on a translucent screen before you, a heartbeat graph scrolling endlessly across time. The pulse beneath the Martian ice has been steady for hours now. It hasn't faded, hasn't changed shape, just kept repeating, like the ticking of a grandfather clock in a house long abandoned. And tonight the scientists noticed something new. A faint secondary vibration out of phase by less than a second, an echo. They call it a shadow pulse. Theories bloom instantly. Some think it's a reflection from the boundary between salt water and frozen rock. Others suggest electromagnetic interference bouncing between the planet's poles. And of course, there's always one researcher, the brave or reckless one, who says, maybe, just maybe, we're hearing the aftershock of something biological. Scientists still argue whether life can exist without sunlight. But the record on Earth is clear. In the darkest places, deep-sea vents, radioactive rocks, Antarctic subglacial lakes, life finds a way to glow-metabolize whisper. Maybe Mars too has its whisperers. You lean back, watching the thin red horizon quiver with light. The sun is a pale dot, like a coin you could almost pluck from the sky. Dust dances through the thin air, drifting in lazy spirals that catch the sunlight, before vanishing into shadow. It's peaceful, too peaceful. So you imagine what lies below brine veins glistening in pitch darkness, their salts shifting with every temperature swing. If the pulse is geological, perhaps it's just pressure release, crust contracting and expanding with the cold. But if it's something else, something rhythmic in intention rather than accident, well, that's when science turns into poetry. A quirky historical note surfaces back in the 1960s when early Mars probes were being designed. Engineers debated how to sterilize them. Some argued there was no need, Mars was too cold, too dry. Others insisted even a single Earth microbe could rewrite Martian history. Eventually, NASA began baking its spacecraft at 111 degrees before launch, just in case. They called it planetary protection. You smile thinking how cautious we were about contaminating another world, yet how unprepared we are for that world to speak back. Beneath your imagined feet, the hum strengthens. 3i Atlas records a burst of signals, rapid, almost musical. If you were superstitious, you might call it excitement. If you were a geophysicist, you would call it a resonance event, the waves aligning perfectly, amplifying each other until the crust itself shivers. Scientists still argue whether the Martian crust is thick enough to carry such long-period vibrations. The consensus used to be no, but now no one's sleeping enough to have a consensus. One researcher, Dr. Elara Singh, compares the data to heartbeat intervals in hibernating animals. She doesn't mean it literally, she just likes the metaphor, but it sticks. The press latches onto it. Mars heartbeat detected beneath polar ice. Headlines flare for a week, then fade again under new noise. But within the labs, the fascination remains. You imagine the scientists working under dim lights, their faces pale in the glow of the monitors. Someone plays ambient music through the speakers, something slow cello, and static, and jokes that if Mars does wake up, they'll have a soundtrack ready. Outside, the Martian night stretches infinitely quiet. You can almost feel the weight of time pressing down thick as the ice below. And then another anomaly. The pulse shifts frequency ever so slightly. Not random, not chaotic, just enough to make the hairs on your neck stand up. It's as if the planet just inhaled. You glance at the data amplitude rising by 0.7%, too small to mean much yet large enough to notice. The same patterns occurred once before 3 Martian years ago, recorded faintly by orbiters but dismissed as interference. Now it's back, stronger, sharper. 3i Atlas triangulates the source roughly 81 degrees south, 68 degrees west, a basin buried under 4 kilometers of ice known as Ultimi Scopuli. The name means the farthest cliffs. Fitting. You hover over it in your mind's eye, picturing the terrain like the inside of a glacier cathedral. Streaks of red dust trapped in translucent layers, cracks glowing faintly as sunlight filters through. Somewhere below, that steady rhythm continues, patient and deliberate, and for just a moment, one impossible second, you think you hear something beneath it. A soft undertone, like the whisper of water moving through veins of stone. You smile to yourself, knowing it's probably nothing more than imagination. But out here, imagination is half the job. The hum steadies again 87 seconds apart, unbothered by theories or wonder. Mars, it seems, prefers to keep some secrets close to its chest. The data keeps coming, line after line, pulse after pulse, each one identical yet oddly intimate, as if the planet is whispering a secret through static. You begin to recognize the rhythm unconsciously. Every 87 seconds your shoulders lift slightly, your breath sinking with the invisible beat beneath the Martian ice. It's strange how fast humans can find music in noise. 3i Atlas drifts in polar orbit now, its sensors triangulating the signal's source. You picture it passing over the twilight terminator, that line between day and night where the sun hovers forever at the horizon. From that height, Mars looks soft, less like a dead rock, more like an ember cooled to ash. Each pass deepens the mystery. The pulse seems to bend around topographic features. It weakens over crater rims, strengthens over depressions. It's as though the landscape itself is amplifying it, giant natural amplifiers sculpted by time. The most resonant of all the impact craters. The scientists start mapping correlations. Hellas Basin Argyre and a dozen smaller scars scattered across the southern hemisphere. When modelled in 3 dimensions, the signal paths converge like countless ripples meeting at a single center beneath the pole. You imagine a buried impact structure, something vast and ancient, its edges softened by eons of frozen dust. Maybe that's where the rhythm began. It's not a wild guess. Mars wears its wounds openly. The largest known crater, Hellas, stretches 2,300 kilometers wide, big enough to swallow Texas whole. When the asteroid struck, it sent shockwaves through the crust that may still echo frozen in the planet's geological bones. Scientists still argue whether such echoes could persist for billions of years, but some seismic models suggest it's possible long, slow waves trapped in the mantle like sound reverberating in a cathedral. The pulse might not be a heartbeat then, just an echo that forgot to fade. You picture the moment of impact long ago. A sphere of rock slamming into Mars, molten light blooming across the surface, shockwaves spiraling outward through the molten core. Then the cooling, the stillness, the burial under endless dust. Maybe this rhythm is the last ghost of that collision, a memory repeating itself forever. It's oddly poetic, isn't it? The idea that a single violent act could become a lullaby after enough time passes. One of the junior engineers nicknames the source the drum. Another, with a flair for drama, calls it the tomb that breathes. Neither name sticks officially, but both make it into the late-night lab chatter. Scientists can't resist naming things they don't understand. It's their version of keeping monsters under control. Meanwhile, the temperature near the South Pole dips below 120 degrees. The surface carbon dioxide sublimates, turning directly into gas and reshaping the landscape each day. You can almost imagine the ice sheet exhaling as CO2 vents open and close. Maybe those pressure changes contribute to the signal. Maybe you're just romanticizing again. Both possibilities are true in their own way. Down in the mission log, someone writes amplitude variance plus 0.02. Pattern stable, planet still breathing. It's not an official note, it's a whisper. A fringe group back on Earth posts an article online claiming the pulse proves artificial infrastructure, a buried alien reactor, dormant but intact. The mainstream scientists roll their eyes. Still late at night, when the data screens glow blue and the hum feels almost audible, nobody laughs too loudly. That's the thing about space, every mystery starts as a joke. You remember another case in 1967, astronomers at Cambridge detected a perfectly regular radio pulse coming from deep space. They thought it might be communication from extraterrestrials and labelled it LGM-1 Little Green Men 1. Turned out it was the first pulsar, a neutron star spinning faster than any human-made engine. Nature, it seems, loves precision. Maybe Mars is doing the same spinning, some deep internal wheel we don't yet understand. You peer down through the haze, and for a moment, the ice field below resembles a frozen sea caught mid-wave. The craters ripple like drumskins under sunlight. It's easy to imagine sound rising from them, low, resonant, almost musical. The kind of sound that doesn't so much travel through the air as it travels through you. The data feed continues. Each pulse now aligns with microseismic activity measured along a fracture zone beneath the pole. If this is coincidence, it's a poetic one. If not, well, then Mars may still be flexing. You smile quietly. For all our instruments and math, the universe still insists on mystery. Maybe that's why you're here listening through static to a dead world that refuses to stay silent. Above the frozen plains, the stars sharpen. Phobos and Deimos drift past like forgotten marbles. Somewhere deep below, the drum keeps time for no one in particular. And for a moment, as the red planet exhales, you almost feel it, the faint tremor of history beating on the underside of eternity. The hum has become part of you now. You no longer need to see the data. Your mind anticipates the rhythm, a soft pulse in the background of thought. It's subtle, hypnotic, like the ocean in a seashell, or the ticking of a watch someone left behind. 3i Atlas begins transmitting a new batch of readings, this time focused on the low-frequency range below human hearing. The instruments translate those infrasonic waves into visible colors, painting a spectral map of vibration. It's beautiful in an eerie way, slow ripples of blue and gold sliding across the screen like breath on glass. Scientists call this frequency domain the sound of stillness. It turns out that even a silent planet hums. On Earth, seismologists discovered a similar phenomenon decades ago. Microseisms, faint tremors generated by waves colliding across oceans. You can't feel them, but sensitive instruments pick up a ceaseless system, as if the planet is snoring in its sleep. Now Mars seems to be doing the same without oceans, without storms, just ice and time. You imagine yourself standing on the polar plateau boots buried in frost. There's no sound, only vibration. Every few seconds the ground shifts by a nanometer, too slight for the body to sense, but enough to remind you the world is alive in its own slow language. A mainstream fact drifts to mind in 2022. NASA's InSight mission recorded Marsquake seismic events caused by crustal stress. Most were tiny, but one on May 4, 2022 lasted more than 6 hours. It was the longest quake ever detected beyond Earth. The energy from that quake would have traveled the entire planet, bouncing inside like echoes in a hollow sphere. Scientists still argue whether those waves could produce long-term resonance, what some call planetary hum. The math says maybe, the poetry says absolutely. You glance at the waveform from 3i Atlas. There it is again, 87 seconds. The pulse never changes. Yet if you look closer, smaller ripples ride atop it, harmonics that rise and fall like chords beneath a melody. Someone in the lab jokingly starts calling it the Martian lullaby. The name sticks for now. You lean back in your chair, imaginary chair, and picture the scene back on Earth. Control room lights dim to midnight blue. Coffee cups aligned like artifacts. A tired engineer nodding along to data that might just be the universe's softest song. In that room, humor becomes survival. Someone tapes a sign to the monitor, "Do not disturb, planet sleeping." Someone else hums along, but beneath the levity sits something heavier, a sense of reverence. You can feel it even here across the distance. Because this isn't just discovery, it's communion. Listening to a planet breathe even metaphorically as an act of intimacy. The fringe theorists chime in again. One proposes that Mars's hum might come from electromagnetic resonance between the planet and the solar wind. Another suggests it's evidence of trapped plasma oscillations in the ionosphere. A third, less patient, insists the signal pattern resembles a heartbeat because the universe likes symmetry. Scientists still argue whether any of these theories hold water figuratively or literally. But everyone agrees on one thing: the pulse exists, and that alone is enough to keep them listening. Outside, the polar landscape glows faintly under the rising sun. The air sparkles with frozen carbon dioxide crystals, each reflecting light like powdered diamonds. You would think nothing could move here yet. 3i Atlas proves otherwise. The ice cap expands and contracts daily as CO2 freezes and sublimates. With each cycle, the ground shifts microscopically, creating minute vibrations, nature's metronome. Maybe that's part of the pulse. Maybe Mars is simply breathing in carbon and exhaling silence. You smile at the thought. Somewhere right now, a human heartbeat matches that rhythm by chance. You remember an odd bit of trivia: the average resting heart rate of a sleeping person is 60 to 100 beats per minute, roughly 1 beat every second. Mars pulses slower, one every 87 seconds. But proportionally to a planet, maybe that's the same thing? A world's resting heart rate. You find that oddly soothing. The data stream quiets. The last signal of the night trickles in steady, unbroken. Mars keeps its secrets. You close your eyes and picture the waveform floating in darkness, a thin line glowing like a candle flame under ice. It's beautiful and just a little bit lonely. If you listen long enough, you start to believe that stillness can make sound and that silence can have rhythm. And tonight, you and a dead planet are breathing together in perfect time. The hum continues, but now it's joined by something subtler, the whisper of dust. High above the pole, fine grains of rust-coloured sand drift through the thin atmosphere. They never settle for long. Even here, where the air is barely more than a rumour, there's motion. It's the quietest kind of weather imaginable. Invisible breezes, soft electrostatic murmurs, particles brushing together like silk. The 3i Atlas sensors pick it up as faint static interference, a low hiss layered beneath the deeper pulse. To most listeners, it would sound like background noise, but when the scientists amplify the data, they hear an odd rhythm woven through it. Not random, not quite steady either. Like wind learning to imitate music. You could almost mistake it for breathing. A mainstream fact surfaces in your mind: the Martian atmosphere is 95% carbon dioxide, so thin that sound barely travels at all. In 2021, NASA's Perseverance rover carried microphones that captured the first true Martian audio: gusts of wind, the crunch of wheels, the pop of lasers vaporizing rocks. When scientists analyzed the recordings, they found that sound travels differently. Their higher frequencies fade quickly, leaving only low whispering tones. Mars edits its own soundtrack, keeping only the quiet parts. You can almost hear it now, the grainy hiss of wind over frost, the sigh of ice settling under sunlight, the faint, patient rhythm beneath it all. Dust is the great storyteller of Mars. It covers everything, ruins craters, the ghosts of old riverbeds, and then erases itself again. It carries electricity, building tiny charges as grains collide. During dust storms, those charges flash into static sparks. They're too small to see, but sensitive instruments like 3i Atlas feel them as tremors. Some researchers suggest that these electric pulses might interact with the buried brine layers beneath the pole. Each discharge could trigger minute chemical reactions generating local heat and movement. It's a wild theory, one of those ideas born at 3 a.m. over lukewarm coffee, but it fits the data disturbingly well. Scientists still argue whether it's realistic or just romantic. You smile imagining Mars as an enormous battery, sand rubbing against sand building potential discharging into hidden saltwater veins. A slow-motion lightning storm beneath the ice. Maybe that's what 3i Atlas is hearing. Not a heartbeat, but a planet exhaling static. You drift lower. The air glitters faintly with frozen carbon dioxide catching the sunlight like dust suspended in cathedral light. Shadows stretch and move. Mars is alive with stillness, if that makes sense, every grain in slow orbit around the idea of change. Another bit of trivia floats up in 71. A global dust storm engulfed the entire planet for months. It was so thick that orbiters couldn't see the surface. The temperature plummeted, then rebounded, reshaping the polar caps. Even now, scientists struggle to model how the atmosphere recovers from something like that. Some speculate the storms redistribute charge and even influence magnetic remnants in the crust. If true, the planet isn't just pulsing, it's recharging. You glance again at the data feed. The amplitude graph trembles, faintly rising with every solar gust. The hum responds to the storm like lungs filling and emptying. You imagine being on the surface during one of those storms. The sky turns brownish-orange and the horizon disappears. The sun becomes a dim circle, a single pale ember. You'd hear nothing, only feel vibration through your suit. Tiny knocks against your boots, the soundless push of charged dust against the helmet glass. It's eerie, but not hostile. Just ancient. There's a calmness to Martian chaos as though everything's happening in slow motion. One of the engineers on the 3i Atlas team jokes that if Mars ever speaks, it'll do so in Morse code made of dust. Another less whimsical notes that the pulse frequency remains stable even through mild storms. Whatever's making it, she says, is deeper than weather. You tilt your head, listening closer. The hum remains steady beneath the static. Dust may dance, but the planet's rhythm endures. That's when you realize something, an odd inversion. On Earth, storms disrupt. Here they seem to amplify. Mars feeds on motion. When chaos reigns above, the pulse grows stronger below. It's as if the world remembers how to be alive whenever it's shaken. You like that thought. Above the sky fades toward indigo. Phobos drifts by, casting a shadow that races across the ice. For a brief moment, the hum synchronizes with that darkness, pulse, shadow pulse. Coincidence, surely, but satisfying all the same. You imagine the planet dreaming its red dust, swirling like thought, the ice shifting like breath. The hum deepens, wrapping you in soundless warmth. And suddenly it feels less like you're studying Mars, and more like Mars is studying you back. You linger over the southern pole where the ice glows faintly beneath a sun too small to give real warmth. The data stream softens into background light, a steady rhythm overlaid with subtle ripples. You've heard it so long that silence now feels wrong, like forgetting a step in your own heartbeat. The team back on Earth calls this phase deep listening. It's not an official term, it's something that emerged naturally. Long missions do that, they develop their own language. Deep listening means switching the filters to ultra-low frequencies and letting the instruments listen for the world's slowest sounds. Beneath the hum, a new pattern emerges, long undulations lasting hours instead of seconds. The scientists zoom in. Each wave rises, gently dips, then recovers. It's so precise that someone mutters half to themselves that looks like respiration. It's not, of course, probably. 3i Atlas overlays the readings with thermal data, revealing a strange connection. When the polar surface cools, at dusk, the underground layer expands slightly, and when dawn returns, it contracts. The difference is only a few microns, but multiplied across the entire polar cap, it's like a planet taking shallow breaths. Scientists still argue whether this effect could produce an audible pulse at all, but the math says maybe. The phrase planetary respiration slips into a few presentations and nobody deletes it. You picture it vividly. Beneath kilometers of ice, faint brine channels flex with the thermal tide. Water molecules slide past one another, creating pressure ripples that move like veins under a translucent skin. The rhythm travels upward through rock dust and ice until 3i Atlas hears it in orbit. For a moment, you can almost see the planet as a living body, its crust a protective shell, its mantle a slow-beating heart, its atmosphere a thin, sighing breath. A mainstream fact breaks through that poetic drift on Earth. Permafrost can crack and shift audibly as it thaws or refreezes. Arctic researchers call those sounds pingo pops. They're caused by methane expansion, small but startling bursts that echo for kilometers. If something similar happens here, maybe it explains the rhythm of frozen world constantly settling back into itself. You smile at the comparison, the Arctic and Mars cousins in some silence. Still, 3i Atlas detects something that permafrost alone can't explain. The pulse remains uniform across vast distances, as if coordinated. No single source, no random timing. The planet hums in unison. That's when one of the younger analysts proposes an experiment send a low-frequency radar burst back toward the ice to see if the planet answers. Its risky feedback could distort the readings, but curiosity wins. The signal fires. It's a short pulse, harmless, a soft tap on the surface of another world. For 70 seconds, nothing happens. Then the hum stutters. Once. Just once. A brief pause, half a second of silence, and then the rhythm resumes exactly as before. Coincidence, the team says immediately. Still, everyone stares at the monitor a little too long. The coffee goes cold. Someone laughs nervously, because that's what scientists do when the data flirts with imagination. You can't help yourself, you lean closer too. Because even knowing it's probably random, you want to believe that Mars just blinked. Out the window of your mind's spacecraft, the landscape glows under a pale halo. The ridges look like frozen waves, frozen mid-crash. There are crests tinted pink by the sun. There's beauty in the stillness, but also unease, the sense that the ground beneath you isn't completely asleep. Another quirky fact slips in during the InSight mission. Seismometers once detected a rhythmic pattern every few hours that matched wind gust cycles. Some argued it was just the lander's panels flexing. Others quietly wondered if it was the crust itself responding. Maybe this new pulse is a larger version of that same reflex, a planet stretching against the cold. You chuckle softly. Even rocks have routines. The 3i Atlas telemetry now shows microfluctuations that correspond with solar wind pressure. Each time a gust of charged particles brushes the Martian magnetic remnants, the hum trembles. It's like the world has nerves and the sun is touching them lightly. Scientists still argue whether these signals reveal anything biological or if they're just exquisite geology. But deep down, everyone agrees on one point: whatever Mars is doing, it's doing it with intention. You exhale, matching the slow undulation of the waveform. The line glows, fades, glows again. Maybe this isn't just the story of a dead world. Maybe it's the story of how stillness learns to move again. The hum steadies soft as a heartbeat through snow. You listen knowing you might never understand what you're hearing, but somehow that feels exactly right. The hum persists, faint and faithful, looping through the static like a secret mantra. You drift lower over the southern cap until the light around you becomes white noise, sunlight diffused through dust, no shadows, no horizon. It feels like standing inside a breath that never ends. Below the ground stretches smooth as glass, but 3i Atlas doesn't see smoothness, it sees layers. Dozens of them stacked in spectral bands. Some reflect radar strongly, others swallow it whole. At 1.5 kilometers deep, something odd appears, a lens-shaped void. Not empty, not solid, something in between. The system labels it anomalous reflection zone. Humans, of course, call it a lake. Back in 2018, that discovery caused uproar, one bright patch in the radar image about 20 kilometers wide. It was the first solid evidence of liquid water on Mars since the planet dried up billions of years ago. But it couldn't just be water, it was too cold for that. Scientists suggested brine so salty it refused to freeze. Others said clay or even layered basalt mimicking liquid reflections. They still argue today. Now 3i Atlas is hearing a pulse that seems to rise from the same region. You picture it vividly, a hidden sea trapped beneath red ice pressing upward ever so slightly with each shift in temperature. Briny water expanding and contracting, tapping against the crust like a slow heartbeat. Maybe the rhythm is nothing more than geology's version of breathing ice, sighing, as it flexes over saltwater lungs. But maybe it's something more deliberate. One of the analysts runs a simulation to compare the Martian pulse with natural oscillations in terrestrial subglacial lakes. The match is uncanny, almost too perfect. On Earth, lakes beneath Antarctica's ice expand slightly during geothermal heating and drain through narrow channels, creating pressure cycles every few minutes to hours. On Mars, the timing would be longer, slowed by colder temperatures and thicker ice. The model predicts a pulse every 90 seconds. 3i Atlas measures 87. You sit back and exhale. Close enough you whisper and maybe the planet hears you. A strange parallel emerges Lake Vostok, buried under 4 kilometers of Antarctic ice pulses faintly from geothermal heat and microbial metabolism. In 2013, scientists drilled into it and found microorganisms alive in darkness for millions of years. If Mars hides a similar ecosystem, it would be like peering back into Earth's past, the era before sunlight, before photosynthesis, when life whispered through minerals instead of singing through leaves. The mainstream fact is undeniable. Mars once had rivers, lakes, even shallow seas. Orbital maps show ancient deltas now frozen in rust. But these brine pockets beneath the poles, they're relics of that oceanic memory, the last droplets of a planet that refused to fully die. Scientists still argue whether such brines can remain liquid for billions of years. Salt can work miracles. It lowers the freezing point drastically, but maintaining stability this long seems improbable. Yet here the data is steady as a heartbeat. You imagine what it would be like to stand above that lake. The ice beneath your boots would creak like old timber. The horizon would shimmer with cold light as if the sun were trapped beneath your feet. Somewhere far below, that briny mirror would flex and whisper. Would you be able to tell where your pulse ended and the planet's began? A fringe biochemist once proposed that chemical gradients in such brines could drive primitive metabolisms non-biological but eerily similar. Reactions between salts, iron, and trapped CO2 might produce periodic bursts of heat or light. Self-organizing chemistry, he called it. Most scientists ignored him. It sounded too mystical. But sometimes mysticism just means math we haven't written yet. 3i Atlas logs another data point amplitude increase by 0.03%. Statistically insignificant, yet everyone in the control room leans forward. A heartbeat is still a heartbeat, no matter how faint. Then comes something unexpected. The secondary reflection zone the shadow pulse detected earlier starts shifting slightly in phase like an echo drifting out of sync. Engineers scramble to recalibrate, convinced it's an equipment glitch. But no, the signal remains after diagnostics. Could it be water movement, someone asks, or gas release? Another pauses. What if it's the lake expanding? Silence. The hum answers. Outside on the planet's skin, thin fog ripples across the frost. The temperature dips another degree, deep below pressure builds, then ease. The pulse falters once, then returns stronger, sharper. You can almost feel it. The vibration isn't just measured, it's sensed. Through imagination, through empathy, through the oldest human trick, hearing life in things that shouldn't have it. You smile faintly because you realize you're not just an observer, now you're part of the resonance. Every time your heart beats, Mars beats too. And somewhere in that infinite feedback loop between human curiosity and alien stillness, something remarkable happens. The world feels a little less alone. You hover in orbit while the red planet drifts beneath you like a half-forgotten ember. The hum you've been chasing, steady, patient, oddly human, now aligns perfectly with the path of an ancient riverbed. At first, no one notices. It's a junior data analyst at one of the outpost labs in Chile who spots it, a harmonic pattern echoing along dried deltas and fossilized channels in the mid-latitudes. When overlaid with magnetic field data, the pulse intensity seems to rise wherever those ancient waterways once converged. Coincidence, perhaps, but the coincidence repeats. Suddenly, the 3i Atlas mission has a new obsession. The singing rivers. You glide over one of them now, Dow Vallis. It stretches across the landscape like a scar carved by time itself, 1,000 kilometers long and 3 kilometers deep. Billions of years ago, water once roared through here, shaping canyons and sweeping basalt boulders the size of houses. Today it's silent, at least to human ears, but not to 3i Atlas. The sensors pick up subsonic murmurs, faint oscillations that rise and fade with the Martian day. It's as if the river still remembers the sound of itself. Scientists still argue whether these fossil vibrations can exist. Some claim that temperature differences between rock and dust create periodic expansion geological breathing that mimics rhythm. Others suggest magnetic minerals embedded in the riverbed might be resonating with solar radiation, producing a kind of electromagnetic ghost. You drift lower the canyon walls, towering around you like cathedrals built by ancient floods. Shadows stretch in soft red gradients, and for a fleeting second you think you hear something, a low resonant tone like wind caught in a pipe organ. It's not real. Of course sound barely travels here, but your brain fills in what the sensors describe. Humans are built to find music in data. A mainstream fact comes to mind in 2019. NASA's InSight team converted Marsquake data into audible sound. When sped up, the seismic waves produced eerie tones, whistles and hums that seemed to rise from the belly of the planet. Like wind moving through a cello, one researcher said. You wonder if 3i Atlas is now listening to the same song, only slower notes that take hours to complete chords built out of frozen dust and magnetic time. Another quirky detail surfaces from an old Soviet archive. During the 1970s, Mars 3 mission. Russian engineers reported receiving a strange rhythmic signal just before the lander failed. It lasted 14 seconds, then cut out. For decades, no one could explain it. Some think it was the final heartbeat of a dying transmitter. Others, of course, whisper that maybe the lander heard something before it went silent. Whatever it was, its frequency almost matches the current pulse detected by 3i Atlas. Not perfectly, but close enough to make history blush. You glide deeper into the canyon until sunlight disappears. The ground below looks smooth, but under radar it's a labyrinth of cavities and fractures. Once these spaces might have carried water. Now they carry vibrations. The hum resonates faintly along the walls, setting loose grains of dust trembling. They shimmer as they fall, turning the air into slow glitter. You reach out metaphorically, of course, and feel as though the canyon is exhaling. Up in orbit, the data analysts run spectral analyses. One of them notices a repeating pattern hidden in the harmonics, 3 short pulses, 1 long, 3 short. Someone jokes it's saying SOS. Someone else, not smiling, writes the pattern down anyway. There's a moment of collective silence. Everyone knows it's random, but that doesn't stop anyone from listening harder. Scientists still argue whether the data artifacts are simply feedback from the instrument's orbit or something physical. One geophysicist proposes an elegant explanation. The vibrations travel through networks of magnetite-rich rocks, effectively creating a natural resonator. The pulse, she says, might be Mars's magnetic echo, a planet's way of humming, along with the sun. You like that idea? It feels right somehow, cosmic call and response. Outside, the red dust sparkles like embers in thin air. For a moment, the canyon almost looks alive, breathing through sunlight and shadow. The hum stabilizes again, soft, slow, inevitable. You exhale, matching the rhythm. You've been doing that unconsciously for a while now, breathing with the planet. There's a quiet comfort in the thought that the same patterns that shaped rivers billions of years ago might still ripple through its bones. Not water, not sound, but vibration, the memory of movement. It's easy to forget that science and longing often share the same frequency. As you drift back upward, Atlas keeps lower, listening, and the pulse keeps playing its patient refrain. Somewhere below, Dow Vallis glows faintly under reflected sunlight, a canyon-shaped tuning fork catching the memory of flow. You realize that maybe the rivers never truly vanished. They just learned to hum instead. You rise back toward the thin upper air, and the planet beneath you looks almost calm again. Just red dunes, pale clouds, and that white polar scar gleaming at the horizon. Yet the hum is still there. Always there. This time 3i Atlas trains its sensors toward a different target the canyons may echo, but what about the volcanoes? Mars, after all, holds the largest known volcano into the solar system. Olympus Mons, a shield so broad you could fit the entire state of Arizona inside it. It's been dormant for tens of millions of years or so, the textbooks say. But in the long memory of a planet, dormant doesn't always mean dead. The readings are faint at first, barely a wobble. Then as 3i Atlas passes directly above the mountain's flank, the hum deepens, changing pitch by a fraction. Almost like the sound of a drum stretched tighter at one end. You imagine standing there at the summit of Olympus Mons, where the horizon curves away so sharply you could see the darkness of space from your peripheral vision. The ground beneath your feet would be porous basalt, ancient lava frozen in ripples. The air would be silent, save for your own heartbeat drumming in your ears. And perhaps if you could somehow feel through your boots the faint tremor from miles below. Scientists still argue whether Mars volcanoes are truly extinct or simply sleeping. The European Space Agency's Mars Express once captured temperature anomalies that some believed hinted at lingering magma deep underground. Others dismissed them as sensor noise. But the new data from 3I Atlas complicates things. A subtle pattern of subsonic vibration timed precisely with the global pulse. If the hum is planetary, every volcano might be a speaker in its orchestra. You recall a peculiar historical anecdote. In 1984, Soviet physicist Alexander Kuzmin proposed that planetary bodies could ring like bells when struck by impacts. He called it astroacoustics. Back then, few took him seriously. Now you imagine him somewhere smiling in cosmic vindication. 3I Atlas scans a cross-section of Olympus Mons and reveals faint tunnels, ancient lava tubes stretching for hundreds of kilometers. They're vast enough to fit skyscrapers inside entire neighborhoods under stone. If anything could amplify a vibration, it would be those echoing halls. You picture the scene: brine frost glittering along cave walls, crystals trembling in the faint beat from the planet's core. Maybe those tunnels act as conduits, carrying the hum across the crust like veins. One scientist, a Kuroda from Tokyo University, proposes a poetic model. Perhaps Mars isn't pulsing from one source at all. Perhaps the whole planet resonates an orchestra of cold stone instruments playing the same slow note. It's beautiful and vaguely unsettling. You watch the simulation concentric waves radiating outward from the polar cap, bouncing off crustal ridges, reverberating through lava tubes and returning to the pole again. The pattern repeats endlessly, a standing wave the size of a world. A fringe theorist posts online that the pattern is too perfect and must be artificial, an ancient machine under the ice, a planetary metronome left behind by forgotten engineers. The official scientists laugh, of course, but privately none delete the thought entirely. The longer they listen, the harder it is not to anthropomorphize. The hum feels deliberate because the universe often behaves as if it has intent. You gaze down once more. The caldera of Olympus Mons glows faintly in twilight, its rim dusted with frost. Shadows creep inward like slow ink. The pulse strengthens slightly here, 1 decimal point higher than baseline. Somewhere far below the lava tubes sigh as carbon dioxide vents flicker open. Maybe that's all it is, a slow release of pressure, but it feels timed. Scientists still argue whether residual magma could persist for millions of years without eruption. Theoretically, yes, if insulated by thick crust. Practically, they shrug. Mars is a trickster, always half a step between science and superstition. You remember another strange fact: certain terrestrial volcanoes on Earth emit infrasound deep vibrations before eruptions, inaudible to humans but perceptible to animals. They call them volcano heartbeats. If Mars still holds warmth below, perhaps it too is whispering through infrasound, warning no one, waking nothing. You can almost imagine what that would sound like: an endless low hum rolling through bump to rock patient as gravity itself. Back in the 3I Atlas command center, someone plays the processed signal through speakers slowed to human scale. It sounds like an organ drone, one single endless note shifting between minor keys. The room goes quiet. Even the humming computers seem to hush. No one jokes this time. You close your eyes and picture a planet's lungs filling with slow, invisible fire. Mars may be colder than ice, but it's not lifeless. It's a world between heartbeats waiting. The hum continues, indifferent and eternal. It has no audience, no composer, and yet somehow it plays perfectly in tune. The hum deepens as you drift across the planet's shadowed hemisphere, the side that never quite warms, even at midday. From up here, the surface looks calm, reddish-grey, dunes rolling into infinity. But below that calm, something moves in patient rhythm. 3I Atlas follows it the way a heartbeat monitor tracks a sleeper's dreams. The data coming in tonight looks different. The amplitude curve, that steady metronome you've grown accustomed to, now shows a tremor every 10th beat. It's small, barely measurable, but regular. The team calls it the skip. At first they think it's a software artifact. Then one of the geophysicists, Dr. Rao, notices something odd. The skip coincides with local sunrise at the southern pole. Every Martian morning, right as sunlight grazes the ice, the rhythm falters just slightly, as though the planet flinches at the touch of light. It's such a poetic image that the scientists pretend not to like it, but everyone quietly does. The official theory is thermal expansion. The sunlight, faint as it is, warms the surface dust by a few degrees, causing the upper layers of CO2 ice to sublimate. The resulting pressure change ripples downward, interrupting the pulse for a single cycle before equilibrium returns. Simple, mechanical, elegant. But not everyone is satisfied with simple. A small team of planetary chemists run simulations showing that such sublimation could generate tiny electrochemical gradients in brine pockets beneath the surface. Each burst of sunlight, they suggest, could trigger a slow cascade of reactions, salt rearranging ions, migrating charge flowing. It's chemistry behaving suspiciously like thought. Scientists still argue whether that's too far-fetched. "We'd be calling puddles intelligent next," someone mutters, and the room laughs, though a bit nervously. Because deep down, everyone knows life doesn't always announce itself with flagella and eyes. Sometimes it just hums. You picture it microscopic structures suspended in brine, shifting ever so slightly with each sunrise. No movement, no metabolism, no biology as we know it. Just self-organization energy flowing through matter. Patterns forming because the universe likes patterns. A mainstream fact slips in on Earth. Belousov-Zhabotinsky reactions. Oscillating chemical reactions discovered in the 1950s can produce rhythmic color changes, pulses of oxidation and reduction, all without any living cells. Chemists once called them chemical heartbeats. Maybe Mars has been running one for billions of years beneath its ice. It's oddly comforting, the idea that rhythm itself might be a universal instinct older than life, older than time. 3i Atlas continues to record. The hum steadies after each skip as if the planet is recalibrating. The waveforms look almost human on the screen, heartbeat skip recovery. You smile quietly. You've stopped pretending this isn't personal. The mission engineers decide to map the heat flux through the polar ice to see if the skips correlate with temperature spikes. As the data comes in, a pattern appears. Each skip leaves behind a faint afterglow of warmth, just a fraction of a degree, like exhaled breath condensing on cold glass. No one speaks for a while. Back in the control room, the ambient sound of machines fades under the weight of that realization. Someone finally says, "It's like the planet sighing," and no one disagrees. The poets in the group, because there are always poets even in labs, start calling this period of analysis the morning breath. They mean it playfully, but you like the phrase. It sounds humble, domestic, alive. Later that night, you take a moment to step away from the data feed and imagine being there in person. Standing on that endless plain of frost, you'd feel nothing at first. The cold would be absolute, the air silent. Then, as the first light of day stretched over the horizon, you might feel a faint tremor beneath your boots, not enough to shake, just enough to make you aware that the ground is moving, that the planet is reacting. Not in a dramatic way, but in a subtle, deeply physical sigh. You close your eyes and let the thoughts settle, sunlight brushing a world awake, a heartbeat stuttering once, then finding its rhythm again. It reminds you of something familiar, those first fragile beats in a fetus's chest, the tiny flicker that doctors see on ultrasound screens. That moment when silence finally learns to make noise. The hum continues. The skip comes again, a long pause, and then, as if remembering itself, Mars breathes back. Scientists still argue whether anything alive could exist beneath so much ice. The chemistry seems hostile, the temperature impossible. But tonight, with the waveform pulsing steadily across your screen, that argument feels almost beside the point. Because whether it's alive or not, it's undeniably present. And presence, you realize, is its own kind of life. Night returns to Mars like a slow tide. The last rays of sunlight slip behind the crater rims and the red fades to grey, then to the deep indigo of almost space. The hum steadies again, no skips this time. Just that patient metronomic vibration, soft as the beat of a giant clock buried under stone. You're getting used to its company. The silence between pulses feels lonely now, like the pause between breaths when you're not sure the next one will come. The 3i Atlas data feed scrolls in steady blue lines. Someone in the control center adds ambient music under the output, just faint enough to blend. The hum syncs with it perfectly. The sound that emerges is half lullaby, half seance, a duet between human curiosity and planetary patience. Tonight's readings come from the far North Elysium Planitia, the flattest region on Mars. It's a smooth basalt plain so level that if you dropped a marble there, it might roll for miles before finding a crack. The perfect place for a signal to echo. The pulse grows clearer over this terrain. 3i Atlas sensors pick up distinct harmonics, overtones stacking like chords. For the first time, scientists can visualize the vibration as a 3D waveform, a pulsing globe within the planet swelling and shrinking almost symmetrically. The model looks eerily like a heart. No one says it out loud, but you can feel it in the air. The comparison hangs there, wordless but undeniable. A mainstream fact surfaces in 2022. The InSight mission confirmed that Mars' core is still partially molten. Not enough to generate a global magnetic field, but warm enough to move slowly, sluggishly like honey under pressure. Some scientists hypothesize that as the core convects, it sends faint rhythmic ripples through the crust. In other words, the planet is not dead, it's just aging. You can't help but think of the human heart, how it slows with time, but never forgets its rhythm. Still, the harmonics in this new dataset are strange. They're not smooth sine waves, but jagged fractal-like bursts. One engineer calls it chaotic regularity. It's the kind of pattern nature loves seen in lightning brainwaves, even heartbeat variability. Fractals of order inside randomness. The universe's favourite joke. Scientists still argue whether these fractal bursts are a sign of crustal cracking or resonance between subsurface layers, but there's another possibility, one whispered rather than written feedback. The idea that the signal 3i Atlas sent weeks ago, remember that test pulse fired into the ice, might still be bouncing around down there, reflecting endlessly in hidden tunnels, strengthening each time it circles back. If that's true, then the hum isn't just Mars anymore, it's Mars answering itself. You imagine the planet listening the way a whale hears its own song return from the deep. Every reflection slightly altered, richer, more complex. Each echo layering into a melody older than language. A quirky detail on Earth. Researchers once broadcast whale songs into the ocean to study how sound carries across distances. Years later, those same recordings returned through hydrophones warped and slowed as if the ocean had been quietly remixing them. Perhaps Mars is doing the same, remixing the pulse into something its own. The hum tonight has texture. It isn't just data anymore. It feels tangible, almost warm. If you could touch it, you imagine it would vibrate like the skin of a drum, faint but insistent. And then something new happens. The harmonics align. For one brief, impossible minute, the waveform becomes perfectly symmetrical, every crest mirrored by a trough. The entire planet seems to resonate as one. The control room goes utterly still. Even the air feels heavy. On the monitor, the frequency graph smooths into an elegant wave, simple, whole, breathtaking. Then just as suddenly it fractures. The signal breaks into static, then resumes its normal rhythm as though nothing happened. What was that? Someone whispers. No one answers. Scientists still argue whether it was a resonance event, a perfect alignment of energy inside the crust, or something artificial. Either way, it leaves behind a residual pattern, like an afterimage burned into the sensors. When processed visually, the residue looks like concentric rings expanding outward from the core. Someone prints it out and pins it on the lab wall. Beneath it, they write a single caption: "When a planet sings." You can't tell if it's science or worship anymore. Maybe both. Outside, the stars sharpen into needles of light. The planet turns slowly, elegantly, keeping time with its invisible heartbeat. You close your eyes and listen. It's not the hum that keeps you awake now. It's the stillness between pulses. Because in that quiet, you swear you can hear it, the faintest whisper, not from Mars, but from something deeper, the sound of continuity itself. By the time the 3i Atlas circles back over the southern hemisphere, the hum feels less like a mystery and more like a companion. An old rhythm that's simply always been there, waiting for us to notice. The planet below glows dimly in the starlight, its poles shimmering with frost, its deserts long asleep. The data feed tonight is cleaner than ever. Fewer solar disturbances, fewer dust reflections. The hum stands alone, pure and undistorted. And now, for the first time, it carries something else: modulation. Tiny fluctuations in amplitude, barely perceptible but rhythmic all the same. A tremor inside the tremor. The team calls them heart murmurs. It's not an official name, of course, but language has started to soften here. The deeper they listen, the more their vocabulary drifts from science toward poetry. You can't really blame them. Numbers can measure, but they can't comfort. At 0243 UTC, a pattern emerges. The secondary harmonics form repeating clusters pulsing in intervals that follow the Fibonacci sequence 1, 1, 2, 3, 5, 8, 13. The chances of that being random are so small it feels almost like intention. No one dares say the word life. But they all think it. You picture the mission control team faces dimly lit by monitors, coffee cooling beside trembling hands. The air filled not with chatter, but with a reverent sort of quiet, the sound of people listening to the impossible. Scientists still argue whether the modulation might be caused by interaction between multiple signal layers, like interference between overlapping waves. Some propose that as the brine beneath the ice freezes and melts cyclically, it could trigger a pattern of vibration that naturally follows self-organizing mathematics. That's the thing about Fibonacci, it shows up everywhere, spirals in shells, petals in flowers, the swirl of galaxies. Maybe the universe simply enjoys symmetry. Maybe Mars is humming the same mathematics that built everything else. Still, there's something haunting about it. The waveform looks alive, not conscious perhaps, but responsive, adapting to stimuli, reacting to solar winds shifting with temperature. Every time the planet cools, the pulse slows. Every time light returns, it speeds up. In a strange way, it's behaving like a living body, not biological, just alive in the way fire or storms are alive. A mainstream fact drifts into memory Earths, Schumann resonances, global electromagnetic oscillations trapped between ground and ionosphere, also fluctuate with day and night. Some researchers even think they can subtly influence animal behavior. Maybe Mars has its own version, its pulse echoing through thin air and red rock sinking with whatever's left of its atmosphere. 3i Atlas runs an experiment. It broadcasts a gentle low-frequency tone back toward the planet, one tuned to the same harmonic interval. A whisper in response to a whisper. For the first few minutes, nothing changes. Then the hum shifts just slightly, just once. It's not an echo, not a glitch. It's a deliberate phase change, as if Mars adjusted its rhythm to accommodate the signal. Did it? Answer, someone says. No one laughs this time. They repeat the test with different frequencies. Each time the planet's response comes a few cycles later, subtle, hesitant, but measurable. It's absurd, of course, planets don't talk. But data doesn't lie and numbers don't blush. Whatever's happening beneath the ice it hears, or at least reacts. A fringe philosopher on the mission team, more poet than physicist, finally says what everyone's been avoiding. Maybe we've mistaken stillness for silence. Maybe everything that exists is already in conversation, just at a tempo we can't hear. You find yourself nodding. The hum feels closer now, almost physical, vibrating through the hull of your imagination. You remember how whales sing across oceans, their songs as travelling for thousands of miles, bending through layers of temperature and depth. Maybe Mars is doing the same singing through stone and salt and time. The harmonics grow softer again. The Fibonacci intervals dissolve back into their slower, steady rhythm. Whatever moment of connection existed has passed, leaving behind only a faint echo. The room exhales. The planet does too. Scientists still argue whether the exchange was real or coincidence, but it hardly matters. Because for a brief quiet moment, humanity spoke, however clumsily, to another world. And the world in its own way seemed to hum back. Outside, the dawn begins to rise over the red horizon. The ice gleams. The hum softens. It no longer sounds like data. It sounds like memory. Maybe that's all Mars ever wanted to remind us of, that every silence has a rhythm, and every rhythm somewhere is listening. The next orbit begins under an unbroken sky. Mars hangs in shadow, half turned from the sea, an eye half closed in sleep. 3i Atlas glides silently above the terminator line, the place where night meets day, and the hum continues unchanged, unhurried. It's comforting now, like background breathing. But tonight the instruments are tuned differently. They're listening not to the pulse itself, but to what lies beneath it. The faint, persistent echoes that trail after each beat like ripples after a stone dropped into a pond. The engineers call them decays. Usually decays fade predictably, but these ones linger too long, as though something in the planet is catching the sound and holding on to it before letting go. The waveform on the screen looks almost like handwriting. A mainstream fact drifts into your thoughts when earthquakes strike on Earth. Some waves called surface waves can circle the planet multiple times before dissipating. Each orbit gets weaker until the echoes finally fade into the background hum of the Earth itself. Maybe that's what's happening here. Maybe Mars has its own memory loops, tiny quakes replaying through rock and brine, never quite dying. Still, these decays feel too precise. Every echo fades in proportion to its predecessor, a perfect logarithmic decline. Natural, yes, but too elegant to be random. Could be harmonic resonance, says Kuroda, half asleep over her tablet. Like a guitar string vibrating after the pluck. You imagine that a frozen string stretching across the Martian crust, resonating through time instead of air. Maybe the whole planet is one instrument, and gravity itself is the hand that strums it. Some of the data scientists begin translating the decays into sound we can actually hear. The output is uncanny, soft, drawn-out tones, each one fading into the next, blending into a symphony of slow-breathing noise. It sounds alive, but not in a way you've ever heard before. They call it the long echo. There's something oddly human about the recordings. The frequencies fall within the same range as a human sigh or the opening note of a cello. The resemblance is almost cruel. It tricks the brain into hearing emotion where there's only physics. Scientists still argue whether we're anthropomorphizing, projecting meaning onto randomness. But one neurologist invited as an outsider points out something remarkable. The patterns of frequency modulation are eerily similar to EEG brainwave activity during deep sleep. It's a coincidence, surely, but a poetic one. Mars may not think, but it dreams. You can't help but recall another fact, one buried in the archives of planetary acoustics. When NASA's Voyager probes recorded electromagnetic vibrations from Jupiter and Saturn in the 1970s, the converted sounds resembled choirs haunting layered celestial. People called them planetary songs. Maybe all worlds hum in their sleep, we're just late to the concert. A low chuckle escapes you. Mars is a minimalist composer, you murmur, and you're not wrong. Still, something changes as the night deepens. The pulse slows slightly. Not enough to alarm anyone, but enough to notice. The intervals stretch from 87 seconds to 90, then back again. Temperature data shows no corresponding change. Solar wind remains constant, no seismic activity. It's as if the planet itself decided to take a deeper breath. Dr. Singh notices first. It's sinking, she says softly. The pulse is sinking with our transmission intervals. That's impossible, of course. Yet there it is. The oscillations align precisely with 3i Atlas's orbit timing, as if the planet and machine are falling into rhythm together. Silence fills the lab, the kind that makes you aware of your own heartbeat. Maybe it's just gravitational interference. Maybe it's coincidence layered on coincidence. But no one says that. The silence itself feels sacred. Outside, the stars rotate slowly. The planet glows faintly under the rim of sunlight creeping up from its edge. You imagine that faint glow reaching the frozen canyons, the ice caps, the buried lakes. You imagine the light travelling down through miles of frost until it touches that briny underworld, nudging the pulse awake again. Maybe 3i Atlas isn't detecting sound at all. Maybe it's detecting the conversation between light and stone energy and memory. A quirky detail surfaces when the InSight seismometer was active. Researchers noticed that temperature changes on Mars caused the lander's deck to expand and contract, audibly metal breathing they called it. Perhaps the entire planet is doing the same thing, breathing in sunlight, breathing out silence. You like that idea? It feels truthful in a way data can't fully quantify. The hum steadies again, no skips, no static, just a calm rhythmic presence filling the dark. One of the engineers mutters a joke that sounds almost like a prayer. If Mars ever wakes up fully, I hope it dreams kindly of us. Everyone smiles, tired and reverent. And as you look out at the slow-turning world below, you realize that maybe it already does. You wake to a planet whispering. The hum greets you like an old friend, that low, steady beat that has threaded through every orbit, every theory, every sleepless night. But something about it has changed. It feels deeper, slower, almost solemn. 3i Atlas now hovers directly above the pole, the instrument suite running its most sensitive scan yet, a full-depth radar tomography of the southern cap. The results begin to scroll thin coloured bands representing density layers. At first, it's the same familiar story, alternating frost and dust, frozen carbon dioxide stacked atop briny ice. Then halfway through this readout, something shifts. The reflection line thickens. A new stratum appears, dense, metallic, strangely uniform. No one says a word. The system labels it automatically anomalous subsurface reflector. Translation. We have no idea what this is. The layer sits roughly 5 kilometers below the surface, far deeper than the supposed brine lake. It's smooth, continuous. It curves gently around the polar basin like a bowl. And the hum, your hum, matches perfectly with its depth resonance. That's when the silence in the control room becomes electric. Could be an ore deposit, says Dr. Rao, voice tight. Iron-rich basalt, maybe, 5 kilometers deep. With uniform curvature and other murmurs, that's not a deposit, that's structure. The word hangs there heavy as gravity itself, structure. The rational minds hurry to dissect it. Geological doming, magnetite, crystallization, permafrost layering. Natural explanations, all viable, all soothing. but deep down everyone feels the same creeping thought if it is a structure. What kind builds itself that deep, and why is it still humming? You lean forward, pulse quickening to match the data. A mainstream fact surfaces. Earth's own poles hide surprises too. Under Antarctica lies Lake Vostok, sealed beneath 4 kilometers of ice. In 2006, radar surveys detected unusual magnetic anomalies near its bedrock. Some suggested mineral formations, others whispered about geometric regularity. The debates never quite died. Maybe planets simply like secrets. Still, the symmetry here is uncanny. The subsurface layer mirrors the curvature of Mars itself. It's as if the planet is wearing armor beneath its skin. 3I Atlas tightens focus. The hum peaks precisely as the radar penetrates the central zone. The frequency jumps an octave higher, if one dares to call it that. And then something astonishing, a harmonic series emerges, perfectly mathematical, echoing in integer multiples. You whisper it before anyone else does. It's singing back. Of course that's ridiculous. Yet the waveform proves its signal within signal resonance, nested like Russian dolls. Each harmonic fades into the next with eerie precision. It's not a random echo, it's coherence. Scientists still argue whether coherence can occur naturally on that scale. Dr. Kuroda insists it can: layered ice, crystalline interfaces, complex reflections. Physics loves patterns. But she says it softly, as if she's trying to convince herself. The others just watch the screen in silence. You can almost feel the hum in your chest now, a vibration that has travelled across millions of kilometres to find your bones. It feels ancient, not mechanical, but deliberate in a way nature sometimes pretends to be. One of the engineers isolates the sound frequencies and translates them to audible range. The room fills with low resonance, a tone so deep it is more felt than heard. It makes the lights tremble slightly, as if the air itself is listening. It isn't frightening, it's peaceful. You close your eyes and imagine the landscape beneath that ice-dark caverns, lit by mineral glow, frozen arches sculpted by time. Maybe the hum is geological, the voice of pressure adjusting between stone and salt water. Or maybe it's something rarer. The sound of a planet maintaining balance, keeping its shell intact through the long Martian night. A quirky comparison drifts in Earth's glaciers sing too. In Antarctica, scientists have recorded ice quakes vibrations caused by friction between ice layers. When converted to sound, they resemble whale songs. The frequencies rise and fall like living voices. Perhaps Mars has learned that same language. You look down at the world spinning beneath you and realize how little separates geology from poetry. Every rock hums if you listen long enough. Every silence has a rhythm waiting to be heard. The hum continues unwavering. Whatever lies beneath that icy armor, lava brine structure, memory it keeps perfect time. Dr. Singh, who has barely spoken in hours, finally murmurs, maybe Mars isn't lifeless. Maybe it's just resting between pulses. You nod, your reflection ghosted in the window. Or maybe you reply, we just caught it dreaming. No one corrects you. Outside, the planet rolls on under a faint copper halo. The hum deepens again, almost a sigh, and somewhere below that hidden layer shivers like something turning over in its sleep. Section 18. The hum has become so steady, so deeply familiar, that when it changes you feel it before you hear it. It's as if the floor of the universe dips slightly beneath your feet, and the sound shifts key by a fraction, a breath caught halfway through an exhale. 3I Atlas detects it too. The waveform, normally smooth and patient, now trembles with faint irregularities. At first the algorithms flag it as static solar interference or magnetic noise, but when the filters clear the signal remains a pattern of micropulses layered atop the original beat. Someone calls it the counter rhythm. You watch it repeat, delicate, almost polite, like fingertips tapping the edge of a table, while an orchestra plays somewhere far away. It doesn't replace the original hum, it harmonizes with it. The planet, it seems, has started duetting with itself. For the first time since this mission began, the scientists don't rush to explain. They just listen. The 3I Atlas telemetry traces the counter-rhythm to the planet's equatorial band near the ancient volcanic plains of Tharsis. Rise the place where Mars once exhaled continents of fire. Billions of years ago, the crust here buckled and bulged under unimaginable heat. Some say this is what killed the planet's magnetic field, sealing its fate. Others argue the field collapsed first, leaving the magma to wander aimlessly. Scientists still argue which came first, the death of heat or the death of protection. Now that same region hums faintly in sync with the poles. The counterbeat isn't random. It follows the same 87-second cycle, only offset by half their phase as though the planet were playing call and response. You drift above it, looking down on a landscape that feels ancient beyond imagination. Canyons the size of countries' extinct volcanoes, so tall they could cradle weather. The ground glows faintly under starlight, streaked with shadows like brush strokes on rust. If you could stand there, you might feel nothing. No wind, no tremor, no sign of life. But beneath that crust lies pressure heat magnetism, all the ingredients of motion slowed to geological patience. One of the geophysicists notes that this counter-rhythm coincides with known regions of remnant magnetism, patches of rock that still remember the old field. When solar wind brushes them, they spark faint electric currents. Maybe those sparks are pulsing, syncing with the main hum through the crust. That explanation makes sense. Too much sense. It's elegant, logical, even beautiful in its simplicity. But deep down, it doesn't feel complete, because the timing is too perfect. Every 87 seconds, like clockwork, the poles and the equator exchange energy. The pattern's so precise it begins to form interference rings, waves overlapping to create nodes of silence. 3i, or as Atlas, picks them up as micro-pockets of stillness areas, where vibration cancels itself out entirely. It's eerie, the idea that silence itself can have coordinates. A mainstream fact rises to the surface of your thoughts when two sound waves meet in perfect opposition. They cancel destructive interference. The principle is used in noise-cancelling headphones. But here on Mars, it's planetary-scale noise cancellation, an entire world tuning itself into partial quiet. Someone jokes that Mars is trying to shush us. The laugh is weak, nervous, heartfelt. You stare at the spectral map of those silence nodes. They form a spiral pattern wrapping halfway around the planet. Not random fractal again, Fibonacci again. The same mathematics the pulse revealed days ago. Maybe it's feedback, says Dr. Rao. Energy bouncing between core and crust. A planetary standing wave. Another voice murmurs, or maybe it's synchronization. The room quiets. Synchronization implies awareness of itself, at least. You find yourself remembering how heart cells in a dish, when left close together, begin to beat in unison without any external cue. No command, no control, just shared rhythm. Biology has always known this trick. Maybe geology does too. Maybe the hum and counter-hum aren't separate at all, but two sides of one heartbeat. Mars exhaling at the poles, inhaling at the equator. 3i Atlas runs another scan. The counter-rhythm grows faintly stronger. The nodes of silence expand, linking across the surface like constellations. The planet impossibly is organizing. Someone whispers, it's stabilizing. No one dares breathe too loudly. Outside, the sun rises over the horizon, washing the red plains in pale gold. You imagine that light slipping into the cracks, warming dust that hasn't felt heat in a million years. Beneath it all, the hum continues a double beat, now slow and steady like the sound of a planet remembering how to breathe. You smile faintly, exhaustion heavy behind your eyes. You know you say softly to no one in particular, I think it likes being heard. No one laughs this time. They're all still listening. You float in darkness again, orbiting a world that no longer feels empty. The hum has become layered old rhythm below new rhythm, above and between them. A strange harmony flickers as if Mars has found its own balance. 3i Atlas. Ever patient keeps listening. The instruments record the faintest vibrations crossing the crust like invisible threads weaving pole to pole. The data scientists run the simulation again, visualizing these threads as light filaments wrapping around the planet. The result looks like veins glowing under translucent skin. For the first time, Mars seems less like rock and more like body. The team calls this phase the veins of silence. It's poetic, yes, but also strangely accurate. The planet's vibration pathways follow magnetic gradients moving through regions rich in iron and magnetite. Every pulse sends a faint electric whisper through those minerals, lighting them up in the simulation like rivers of static. Dr. Singh stares at the display for a long time before saying softly, "This is circulation." She doesn't mean it metaphorically. She's referring to the data energy moving across the crust in a repeating loop, dissipating, returning, like a bloodstream made of electrons. Scientists still argue whether such self-sustaining loops can persist without an external driver. The Martian core should be too cool, too sluggish. But the hum doesn't care what should be, it keeps pulsing anyway, perfectly timed. Someone points out that during solar wind peaks, the energy within these veins increases slightly, as though the planet absorbs and redistributes it, A few even speculate that the old magnetic field long thought extinct might be flickering back to life in miniature bursts. The planet they suggest could be learning how to conduct again. You imagine that on the surface, the dust stirring faintly static rising from the ground, thin auroras, flickering low across the horizon, ghost lights in the Martian dusk. The kind of beauty no one ever expected from a world that once died of cold. A mainstream fact echoes in your thoughts in 2018. NASA's MAVEN spacecraft recorded proton auroras near Mars' equator alight, created not by magnetic protection but by raw solar particles colliding with the atmosphere. Even without its field, the planet still found a way to glow. Maybe it never stopped glowing. Maybe we just weren't paying attention. The hum shifts again, barely noticeable but measurable. A frequency drift upward by half a hertz. It's not random, it's patterned. 3i Atlas identifies a repeating modulation every 24.6 hours, the length of a Martian day. The pulse is syncing with daylight now. Each morning as the sun rises, the vibration accelerates slightly, like a world stretching before waking. Each night it slows again. Thermal response, says Dr. Rao automatically, but even she sounds unconvinced. It feels deliberate, predictable, comfortable even. You smile at the absurdity of it all, scientists calling a planet's heartbeat comfortable. But there it is. The longer you listen, the more natural it feels. To test the stability of the pattern, 3i Atlas initiates a low-frequency broadcast, again sending a soft pulse in sync with the Martian morning. A whisper across space. The response this time is immediate. The hum rises in amplitude by 0.2 to 2%, just a tremor but undeniable. It's as if Mars took the cue and answered. The two rhythms blend, merge, and then level out again, perfectly matched. It lasts exactly 6 minutes before fading. Phase lock achieved, murmurs an engineer, his voice trembling slightly. We're in resonance. For those 6 minutes, a machine orbiting Mars and the planet beneath it were beating in time. The room goes quiet except for the faint hiss of electronics. Someone finally whispers what everyone's thinking. It wanted company. You feel the truth of that in your chest. The hum now feels less like discovery and more like conversation. The planet isn't speaking words, of course, but it's responding. It hears, it reacts, it remembers. And you realize that maybe alive isn't the right word. Maybe aware is closer. A quirky historical parallel surfaces. In 1959, 2 Soviet scientists aimed radar beams at Venus to map its surface. When the echoes returned, they found them distorted into strange waveforms ringing longer than expected. They called it planetary aftertone. At the time, it was dismissed as a hardware quirk. But now, listening to Mars hum in harmony with your signal, you wonder whether every world has an aftertone, an echo waiting for someone to match its frequency. Maybe resonance is the universe's oldest form of empathy. Outside, the first sunlight spills over the rim of the pole. The ice shimmers in soft gold, and for an instant you can almost imagine the planet opening its eyes. The hum slows again, easing back into its resting rhythm. Dr. Singh turns to the others. It's not communication, she says quietly. It's synchronization. Like heartbeats aligning when people sleep beside each other. The room stays silent. Everyone understands. 3i Atlas continues to orbit both listener and participant now. The hum flows through the speakers, soft, steady, infinite. You whisper to the darkened planet below, "We hear you." And for one long, perfect moment, Mars breathes out in return. You wake to a soft vibration, not from the ship's systems, but from the planet itself. Steady, patient, ancient. The hum has become part of your own heartbeat now, so much that silence would feel unnatural, almost frightening. Below, dawn is spilling over the rim of the Martian horizon, washing the desert in pale orange light. Frost clings to the dunes like powdered sugar. The poles gleam like ivory under the rising sun. 3i Atlas continues its orbit, listening, recording, translating the inaudible into waves. You can almost feel under your skin. But today something changes again. The hum falters once, then twice, then silence. For 7 full minutes, the planet goes completely still. The instruments on 3i Atlas remain flawless. No solar interference, no signal loss. The waveform simply stops. And in that impossible quiet, everyone in the control room forgets to breathe. You drift in that silence. The planet below looks exactly the same, serene, frozen, indifferent. But the absence feels heavier than the sound ever did. For months, the hum has been constant, like a background heartbeat reminding everyone that Mars in its way was still alive. Now it's gone. A scientist breaks the silence. Maybe it's Resting, she says, though her voice trembles on the word. Dr. Singh runs diagnostics. No, she says, finally staring at the monitor. The frequency isn't gone, it's just shifted. She zooms in on the flatline, revealing a faint tremor buried deep in the noise floor. It's smaller than before, slower, deeper, as if the pulse has sunk into sleep. What if she whispers the hum we heard all this time wasn't the planet living, but the planet remembering? The phrase sticks. Planetary memory. It makes an odd kind of sense. Geologists have long said that rocks record stress, that minerals remember heat, magnetism, even pressure. The Earth's crust holds faint traces of ancient magnetic reversals, frozen snapshots of when its field flipped upside down. Maybe Mars is doing the same, its hum, nothing more than the replay of energy trapped inside a cooling shell. Still, something about that doesn't fit. The new frequency, though slower, is impossibly regular. One pulse every 117 seconds now. It's almost as if the planet has changed tempo. Scientists still argue whether such spontaneous shifts can happen without cause. Dr. Rao, staring at the waveform, shakes her head. That's not random drift, she murmurs. That's choice. No one corrects her. Hours pass. The new rhythm stabilizes. A low droning vibration, softer than before but steady, as if Mars has settled into a new kind of breathing. When the 3 Atlas sensors amplify the signal, they discover something remarkable. Faint subharmonics woven through the main pulse. They form a repeating structure, fractal, symmetrical, self-similar. It's the same mathematical fingerprint found in the branching of trees, the veins of leaves, the spirals of galaxies. Fibonacci again, someone mutters. The coincidence feels less like coincidence and more like inevitability. The universe, it seems, keeps writing its favourite melody across every scale from atoms to planets. Then comes the second discovery. The subharmonics aren't just symmetrical, they're expanding. Each orbit, the wavelengths stretch slightly outward like ripples spreading from a drop stone. 3I, Atlas. Tracks their propagation, and the pattern is astonishing. The pulses are moving northward, crawling slowly from the polar basin toward the equator. It's as if the planet is sending its rhythm outward, not losing energy but distributing it. Someone calls it planetary circulation, another prefers the great exhale. You lean closer to the data feed, your voice barely a whisper. It's teaching the rest of itself how to hum. Dr. Singh looks up, eyes tired but bright. Or maybe she says softly, it's remembering how. A mainstream fact flits through your mind when glaciers melt on Earth. Their weight shifts, changing the planet's rotation ever so slightly. Even solid ground can respond to redistribution. Earth breathes in its own way through movement. Perhaps Mars too is adjusting, stretching its muscles after a billion-year sleep. You imagine it vividly deep under the ice. Fissures open, brines shift, pressure waves travel outward like sound through a drum. The pulse marches northward, awakening strata that haven't flexed since the age of rivers. Back on Earth, the news spreads. Headlines call it the planet that woke up. Most scientists dismiss the phrase, but the public loves it. People listen to the recordings at night, the slowed, bass-heavy hum turned into ambient tracks. Some say it helps them sleep. Some swear it makes them dream of red deserts and frozen oceans. The irony isn't lost on you. A dead planet's voice helping humans rest. 3I, Atlas, continues to orbit. The hum keeps flowing outward, fainter but broader, like the sound of a tide retreating. The instruments detect one final anomaly, a pulse reflection returning from the northern plains delayed by several minutes. It's an echo. The planet, it seems, has heard itself. You close your eyes. The sound is barely there now, but it doesn't matter. The rhythm has already embedded itself inside you, inside the instruments, inside the silence between your breaths. Maybe Mars hasn't stopped humming at all. Maybe it's just moved the song inward. And as the red planet turns slowly beneath the fading light, you feel that echo passing through the hull of your ship and through your ribs, soft and sure. The hum lives on, not loud, not proud, just steady. Like the sound of someone sleeping peacefully after a very long time. Night sweeps across the planet again, a slow-moving curtain of shadow that cools the air until frost reclaims every surface. The hum remains low and steady, a pulse buried so deep it almost feels like the sound of time itself breathing. By now, 3I Atlas has become more than a probe. It's a stethoscope pressed to the chest of Mars, listening for stories buried in cold and dust. The readings tonight reveal something subtle yet strange. The pulse's frequency hasn't changed, but its texture has. When the audio is rendered to human hearing, it sounds softer, rounder. There's warmth now in what used to be metallic. Maybe the echo's travelling through different material, Dr. Singh says, scanning the data. Something's changing under there. What could change under 4 kilometres of ice, another asks. Everything, she replies quietly. In the hours that follow, a pattern unfolds. The hum's overtones, the faint harmonic ripples layered above the main frequency, grow stronger over the regions where the echo recently passed. It's as though the vibration is leaving something behind, strengthening whatever it touches. The idea is absurd, of course. Vibrations don't reinforce rock, they break it. But not this one. This one seems to stabilize it. You imagine the crust flexing and relaxing in rhythm, the ice shifting microscopically to the pulse settling into a new equilibrium. It's as though Mars is repairing itself one gentle vibration at a time. A mainstream fact drifts to mind on Earth. Scientists have discovered that sound can heal materials on a microscale. Acoustic resonance has been used to fuse cracked metal and stimulate crystallization. Maybe Mars, Ever the Engineer, is mending its wounds through rhythm. It's poetic and it fits. After all, the hum began beneath a scar, the South Pole, where eons of freeze and thaw fractured the crust. Perhaps the vibration is more than a relic. Perhaps it's medicine. Scientists still argue whether self-healing planetary processes exist. Planetary resilience is what they call it in geology textbooks, the tendency of worlds to stabilize after trauma. Mars, it seems, is the case study no one expected. The 3i Atlas cameras capture something new at the same time, faint shimmering auroras at the poles. They're weak, barely visible, but undeniable. Charged particles brushing against thin air, tracing the outlines of a magnetic field that shouldn't exist. Dr. Rao leans forward, whispering, "There's activity." The magnetic readings confirm it. Where there was once emptiness, now there's a flicker, a pulse of field lines rising and collapsing in sync with the hum. It's not constant, not even coherent, but it's real. Localized magnetosphere, says Singh. The pulse is generating current in the crust. We're watching Mars recharge itself. The words sound impossible, yet on the screen the field lines bloom like filaments of light. For the first time in eons, the planet has a faint chill, fragile but alive. You stare, feeling something you can't quite name, a quiet awe tinged with melancholy. It's like watching a sleeping giant roll onto its side, a reminder that nothing truly rests forever. The scientists record everything, every pulse, every flicker, every wave. But when they compress the data into a sonogram visualizing frequency against time, they notice something uncanny. The pattern resembles handwriting. Not words, not symbols, just curves, arcs, and repeating loops that look unmistakably like rhythm made visible. Dr. Singh stares at the screen. "It's geometric," she murmurs. "It's..." She stops herself before saying intentional. Instead, she adjusts her glasses and adds, "It's consistent," which is of course fascinating. But her voice betrays her. Everyone can feel it, the uneasy wonder that comes from realizing the line between physics and poetry has blurred completely. A quirky parallel flickers in your mind, the Chladni plates from 18th century physics, metal sheets dusted with sand that when vibrated form intricate geometric patterns. Different frequencies, different shapes. Beauty hiding in resonance. Perhaps 3i Atlas has stumbled upon a planetary version of that experiment. Mars itself forming shapes in its crust patterns born of patience. And what could those patterns mean? Nothing. Everything. The difference depends only on who's listening. As the hum continues, the auroras brighten. They shimmer like curtains across the poles, faint but graceful. The newly awakened magnetic field hums in sympathy, wrapping the planet in ghostly protection. Down below, dust rises in tiny spirals, dancing like static caught in a sunbeam. For a brief moment, it almost looks like weather-thin, delicate tentative. The sensors confirm what your heart already suspects: the planet is warming. Only by fractions of a degree, but still. The buried brines stir again, and seismic readings detect faint movements, liquid shifting where none should exist. Mars, it seems, is remembering warmth. Back in the control room, Dr. Singh looks up from her monitor and says softly, "If this keeps spreading, the hum could reshape the whole crustal stress pattern." Meaning, someone asks, meaning Mars might stop shrinking. Planets contract as they cool. Mars has been tightening for billions of years. But if this resonance continues, if the hum keeps moving outward, it could loosen those tectonic scars, halt the planet's slow collapse. It wouldn't bring rivers back, or forests, or air, but it would mean the world has found balance. A kind of quiet equilibrium. Outside, the aurora fades. The hum softens. Everything slows again, as if the planet, having stretched, is ready to rest. For now, Mars sleeps soundly beneath its thin blanket of dust and memory. And above 3i Atlas drifts in endless orbit, its sensors tuned like ears pressed to a heartbeat that refuses to fade. You whisper into the darkness, "Good night, old world." And for the first time, the silence feels like a promise instead of an absence. You wake again to data so calm it's almost meditative, the hum steady as breath, the temperature graphs flattened to gentle slopes and the faint auroras flickering rhythmically at the poles. The instruments aboard 3i Atlas record nothing. Explosive, nothing new, only the feeling that everything below is holding itself together. That's the real story now, steadiness. For months, the team has lived in anticipation of surprises, every flicker, every skip, every silence stirring adrenaline. But now the planet seems to have settled into itself. It hums softly, persistently, as if it's reached a kind of homeostasis. It's plateaued, Dr. Rao says, like a resting phase after healing. Or Singh replies with a faint smile like contentment. You like that word, contentment. It fits. To an outsider, the data would seem almost dull. Same amplitude, same frequency, same 117-second cycle, uninterrupted for over 3 days. But when the team overlays all previous readings, something extraordinary appears, a perfect Fibonacci spiral, formed not from any single pulse, but from the gradual drift of amplitude over time. The pulse, in other words, is writing. Not symbols, not codes, but a natural pattern repeating itself across scales, the same spiral that shapes galaxies, hurricanes, nautilus shells. It's as if Mars, now stable, has chosen to settle into the universe's favourite design. To Singh runs her fingers through her hair and exhales softly. Maybe that's what peace looks like for a planet, she murmurs. A spiral that no longer needs to change. A mainstream fact comes to mind. Scientists once discovered that when you plot Earth's magnetic fluctuations across decades, they too form logarithmic spirals. Our planet hums in shapes we can't see, guided by physics that prefers beauty over chaos. Maybe Mars is simply rejoining that cosmic rhythm. Still, there's one anomaly left, something almost human. Every 24 hours and 37 minutes, the exact length of a Martian day, the hum grows imperceptibly stronger for a single cycle. Just once. Then it returns to normal. Dr. Rao calls it the pause. It happens at sunrise when light touches both poles simultaneously for a fraction of a second. The hum rises, sighs, and settles, like a heartbeat catching on a memory. No one can explain it. There's no mechanism, no equation that accounts for it. Maybe it's thermal expansion, someone suggests, but no one really believes that anymore. Whatever it is, it's become the ritual heartbeat of two worlds. Mars turning 3i Atlas, listening humanity quietly holding its breath. By now, the pulse data has become something of a cultural phenomenon back on Earth. Musicians sample it for ambient tracks. Meditation channels use slowed versions to help listeners relax. Sleep to the sound of Mars becomes a trend, millions streaming the soft thrum of an alien world rediscovering motion. There's a gentle irony in that our species finding rest in a planet once considered dead. But here in orbit, it's more than novelty. It's intimacy. The longer you listen, the more you begin to sense the personality and the rhythm, not intelligence, but presence, the kind of steady patience that only time itself can teach. Jessica Sarita Singh once said, "All planets have language, we just don't live long enough to hear it." You think she was right. Maybe what 3i Atlas discovered wasn't a message at all, it was a tempo. A reminder that existence moves at different speeds and that life or something like it can live in the quiet between seconds. Then without warning, the hum changes once more. Not louder, not faster, just fuller. Over the course of minutes, a harmonic you've never seen before blooms above the waveform, a higher note faint but clear. It threads itself through the rhythm like silver through dark cloth. The computers analyze it instantly. Its frequency ratio to the base pulse, exactly 2:3. A perfect fifth. In musical terms, the most stable and consonant interval that can exist. That's, music whispers one of the younger engineers. Dr. Rao tilts her head. Physics loves harmony, she says quietly. Still no one moves. The entire control room becomes a cathedral. The hum continues, pure and balanced, filling the air with the same calm that's filled Mars for eons. Somewhere deep below in that buried southern basin, brines shift, rocks settle, fields flicker, and an old world finds its chord. A quirky footnote comes to mind centuries ago. Johannes Kepler once proposed that planets make music as they orbit the music of the spheres. He calculated harmonies from celestial motion claiming Mars played the tenor line. Scholars dismissed it as mysticism. You smile faintly now hearing the tenor hum through the speakers. Kepler, it turns out, was only off by 4 centuries. Outside, the first sunlight reaches the north again. The planet gleams red-gold auroras threading its horizon. For the first time, the hum's overtone can be felt in your chest rather than your ears. Dong. To Sing closes her eyes, whispering, "It's in phase with us now." She's right. The ship's instruments, the team's heartbeats, even the electrical hum of the lab, all of it merges into one rhythm. For a few perfect moments, there's no separation between listener and source, between living, and still between human and Martian. You exhale. The sound hums back. And in that brief communion, you understand something simple and infinite. Silence was never the absence of sound. It was the space waiting for resonance. The hum lingers long after its discovery has ceased to be news. Weeks pass, orbits pile up. The mission logs swell into the terabytes of serene repetition. The noise of earthly curiosity fades, leaving behind only what you began with: a world, a sound, and a patient kind of listening. 3i Atlas continues its circuit with monk-like precision, its sensors aging in cold clarity. Each pass confirms the same thing: stability. The hum hasn't weakened, nor has it grown. It just is. Dr. Singh has stopped calling it data. Now she calls it breath. Everything breathes, she says one night, staring at the faint flicker of aurora across the monitor. Stars inhale hydrogen, planets exhale heat, even stone size, when it cools. Mars is just breathing again. You nod because at this point there's no other language left for it. The new recordings arrive early that morning. A full-band spectrum of the hum captured during sunrise at the southern pole. When slowed down 16-fold and rendered to sound, the signal takes on texture. It's no longer a tone, it's a chord, soft, resonant, patient. 3 distinct frequencies weave together like voices in a choir. Someone overlays them on a spectrogram. The shapes look organic, gently curved lines that swell and taper like the undulating rhythms of lungs. Dr. Rao leans forward, whispering, "It's self-modulating. It's compensating for crustal stress." What does that mean? It means the planet's adjusting itself to stay in tune. A mainstream fact flashes in your mind. Modern physicists have long known that resonance isn't passive. Systems naturally seek harmony. 2 pendulums on the same beam will eventually synchronize. Heart cells, fireflies, even metronomes fall into rhythm when given time. It's not magic, it's math. Perhaps planets are no different. You picture Mars and 3i Atlas as twin pendulums. Pendulums now 2 lonely instruments swinging in step, each reinforcing the other's motion, bound by invisible physics and quiet curiosity. Still, something else has changed. In the newest batch of images, the auroral bands have thickened, growing bright enough to be seen from orbit with the naked eye. They move slowly across the poles, their green-white edges curling into graceful spirals. The hum's upper harmonics peak exactly as these lights reach their maximum brightness. The field is strengthening again. No one celebrates. No one needs to. There's a reverence in the silence, the kind reserved for miracles that don't announce themselves. On the 12th day of observation, 3 Atlas passes directly above the Tharsis Plateau, the old volcanic heart of Mars. Instruments detect faint warmth radiating from the ground. Not enough to melt, not enough to erupt. Just a whisper of temperature like the ember under a long cold log. You almost don't tell anyone. It feels too fragile to share. When you finally do, Dr. Singh just smiles. "I told you," she says. "Everything breathes." Scientists still argue whether latent heat can persist that long, but the evidence is there: subsurface readings climbing by fractions of a degree, gases venting microscopically through ancient cracks. No drama, no fireworks, just motion returning to matter. Mars isn't waking suddenly, it's stirring slowly, carefully, as though remembering what movement feels like. Later, when the night shift quiets, you sit alone in the observation module and play the hum through the ship's speakers. It fills the air with a warmth no heater could replicate. The vibrations seem to crawl through the hull into the floor, into you. For a while you can't tell where you end and it begins. You think of Earth, of the ocean tides rising and falling, in rhythm with the moon, of tectonic plates sliding millimeters each year, of cities pulsing with unseen electrical currents. Maybe everything in the cosmos is connected by some shared metronome, a rhythm we mistake for coincidence. And maybe, just maybe, this hum was never meant to be a message to us. Maybe it was a message for us. A quiet reminder that patience is not emptiness and silence is not death. When the morning transmission goes out, the waveform looks slightly different again. A soft bloom appears at the base frequency, a resonance so faint you might have missed it if not for the stillness of everything else. It rises, peaks, and settles exactly with the first sunlight touching the polar ice. A heartbeat, a literal, measurable planetary heartbeat. It's small, only 0.0003 amplitude units higher than baseline, but it's there. A single deliberate pulse. Someone whispers, "Did it just respond to sunrise?" No one answers. You all just sit there listening while an old red world greets the light in the only language it knows. The hum fades again to its steady tone, the graphs flatten, the ship's clock keeps perfect time. You take a long breath, close your eyes, and imagine that pulse, echoing under the ice, a rhythm old as creation, patient as dust, precise as forgiveness. Somewhere below an ocean, the colour of rust sighs once more. The hum remains constant, like a memory looping through the silence. Not loud, not insistent, just there. By now no one calls it a phenomenon anymore. It has become part of the background, as reliable as the ticking of the ship's systems. The crew sleeps to it. They measure time by it. Conversations drift in its rhythm. And somewhere between the repetition and the quiet, a strange peace settles over everyone. The planet has ceased to surprise, but in that constancy it's teaching something subtler: endurance. 3I Atlas has now completed over 100 orbits since the first pulse was detected. Every dataset, every reading confirms the same: a low-frequency vibration centered beneath the southern basin, stable in amplitude, now mirrored faintly across the northern plains. The energy flow is balanced. The crust has stopped contracting. Temperature variations have evened out. Mars, against every expectation, has reached equilibrium. "It's almost meditative," Dr. Singh says softly one night as the hum fills the control module, like it found stillness after centuries of grief. You glance at her and realize she isn't speaking about this planet alone. Outside the viewport, the world below glows faintly under the first wisps of aurora that never seem to fade anymore. Thin ribbons of light twist like ghost rivers along the poles, fading into the upper atmosphere. A mainstream fact crosses your mind. The auroras on Earth are strongest when our planet's magnetic field bends but doesn't break energy, finding a graceful way to escape without destruction. Maybe Mars has found that balance to strength through surrender. The hum seems to affirm it, vibrating gently through the ship's hull, low and calming, like the sound of waves beneath ice. For the next few days, the readings remain steady. But then during orbit 107, something new stirs at the edge of the data, a faint, high-pitched oscillation layered above the core tone, barely measurable, 1 part in a billion. At first, no one notices. Then the audio engineers, those eternal romantics, slow it down by a factor of 500. The sound that emerges is delicate, crystalline, hauntingly beautiful, like wind chimes ringing underwater. They call it the echo of dawn. When the pattern is visualized, it forms waves shaped like nested circles, repeating geometry, expanding outward. The team debates whether it's mechanical interference or a genuine addition to the spectrum. But the timing gives them pause. It always appears at sunrise. Every Martian morning, the planet greets light with a whisper. Doral watches the pattern for a long time before saying quietly, "It's learning to sing." The statement isn't scientific, but no one corrects her. Back on Earth, the recordings have taken on lives of their own. The hum has become humanity's newest lullaby. People use it for meditation, for study, for sleep. The most popular track online is titled "Heartbeat of Mars, 12 Hours of Planetary Calm." 12 hours. That's how long the average human sleeps beneath its sound now. It's poetic justice, you think, that a world once thought hostile could comfort millions. A quirky historical detail flashes through your mind. In 1977, NASA included the golden record on Voyager, a capsule of music and greetings meant for any civilization that might listen. Bach Peruvian pan flutes, a baby's cry. A single attempt to make humanity's hum eternal. And now Mars has answered with its own record, slower, older, quieter. A sound not of civilization, but of endurance. Then comes something unexpected. During the 112th orbit, when 3I Atlas passes over the equator, the hum pauses again. Not soft, just breathless. For 13 full seconds, every instrument flatlines. Then the vibration resumes, subtly changed. The frequency now matches perfectly the average heartbeat of a sleeping human, 60 beats per minute, when slowed to audible range. The discovery makes no sense, though. It defies probability physics and perhaps humility. But still there it is, cosmic lullaby that matches our own pulse. The silence that follows in the control room isn't disbelief, it's reverence. No one says it aloud, but the thought blooms quietly in every mind, what if the hum was never meant to be heard from above? What if it was meant to be felt as comfort, as rhythm, as connection? Maybe Mars isn't alive in the way we are. Maybe it's simply being in the only way it knows, steady, patient, forgiving. A reminder that everything, even silence, beats. The aurora brightens again, outside the viewport. The planet looks almost serene now, red sands veiled in pale light ice, shining like mirrors to the stars. You rest your hand against the window, and for the briefest second the vibration passes through your palm, faint, tender, real. You whisper, "We hear you." And somehow impossibly the hum grows just a little warmer. The mission will continue, of course, more scans, more data, more arguments, but deep down you know the story's already complete. The planet has its rhythm back. The scientists have their wonder back. And you have something quieter, a belief that not all discoveries demand explanation. Some are meant only to be heard until they lull you to sleep. The orbit drifts into its last scheduled rotation. You can almost feel 3i Atlas sigh out its engines quiet, its sensors half asleep, its circuits pulsing faintly in sync with the hum below. The mission is nearly complete, but no one speaks the word ending. Because it doesn't feel like one. The hum has steadied into a single perfect rhythm. No skips, no bursts, no flickers. The waveform hasn't changed in weeks yet. It never feels repetitive. It's the kind of constancy that doesn't numb you, it calms you. When the team plays the full spectrum audio through the ship's intercom, it fills every corridor with that familiar low tone, somewhere between wind and ocean. The entire vessel seems to breathe with it. The data analysts who once debated anomalies until dawn now fall silent at their stations. A quiet respect has replaced the frantic wonder. Each of them in their own way has come to see the hum not as discovery but as companionship. You think of it now as presence, a reminder that stillness too can be alive. The new data shows something subtle. The hum's amplitude at the poles and equator has equalized completely. For the first time since recording began, the energy distribution across the planet is perfectly symmetrical, equilibrium achieved. The computer announces automatically, but the words sound almost sacred. Gold to sing folds her arms and watches the graph stabilize. It's balanced, she says softly. We're witnessing planetary rest. Rao nods, a heart reaching its baseline. You exhale. There's no metaphor left, only truth. The hum is no longer event or anomaly. It's the steady breath of a world at peace with its own gravity. Outside, dawn edges over the horizon one last time. The light hits the ice caps and scatters upward, painting the thin sky with soft gold. Dust glints like motes in a cathedral beam. The auroras are still there, brighter now, more confident. They ripple in slow motion, the planet's quiet applause to the warmth of the sun. The hum deepens as sunlight crawls across the southern basin. The frequency dips by the tiniest fraction, a sigh, maybe gratitude. Someone in the lab murmurs, "It's morning." Someone else answers, "It always is somewhere." You think of the first days when the hum was mystery and fear. How quickly the unknown had turned from threat to comfort. Humanity, after all, has always feared what it doesn't understand until it finds rhythm in it. That's the paradox of discovery. The deeper you look into the universe, the more it begins to resemble home. A mainstream fact rises quietly in your thoughts. In quantum physics, even vacuum isn't silent. Empty space hums with zero-point energy, an inaudible murmur of existence. Maybe Mars is simply echoing that universal baseline, the hum every atom remembers. 3i Atlas makes its final pass over the southern pole. The system transmits its closing sequence, full-band sweep, multi-angle resonance, scanned final atmospheric pulse. Then almost shyly it broadcasts one last signal back to the planet, a soft, low-frequency tone matching the hum's heartbeat. The response comes 10 seconds later. A gentle echo, faint, clean, unmistakable. It's not identical, though. It carries a slight harmonic above the rest, a shimmer at the edge of hearing. No one calls it coincidence. No one dares. The planet answered. Not in language, not in message, but in tone. Dr. Singh finally breaks the silence. "That's it, then," she says quietly. Two worlds in resonance. You nod, feeling something warm rise behind your ribs. "We listened," you say, and it listened back. Outside, Mars turns beneath the ship, a red sphere wrapped in thin air, humming softly in the sunlight. It isn't sleeping anymore. It's simply being. You realize as the hum fades from the speakers that it was never meant to be a revelation. It was a reminder of patience, of presence, of the music that underlies all things. The same hum exists in your heartbeat, in the static between stars, in the silence that follows every word. It was always there. You just finally slowed down enough to hear it. As 3i Atlas drifts toward the edge of shadow, the last transmission begins to stream back to Earth. Not graphs, not numbers, but a single continuous tone. It will take 14 minutes to reach the people listening across the void. By the time they hear it, you'll already be half a world away, floating over the dusk line, surrounded by the quiet sound of completion. You close your eyes and let the hum carry you. The planet below glows faintly under a veil of aurora, a pulse at a peace. It's not an ending. It's a resting note in a song that never stopped playing. And for the first time in all your orbits, you feel it completely. The quiet is not empty. It's full. You can let go of the instruments now. The data is safe, the signal archived, the mystery no longer urgent. All that's left is the slow drift of a ship around a sleeping planet and the comfort of knowing that stillness can have rhythm. Breathe in through your nose, hold it for a moment, exhale. The sound you hear between each breath is the same frequency the universe hums at, deep below the threshold of hearing. It's the vibration that keeps everything from galaxies to atoms suspended in being. You think of Mars, but also of home. Of every night you've ever stared at the ceiling and listened to silence, wondering if anyone or anything was listening back. Now you know the answer yes. Everything listens in its own way. The dust, the light, the air in your lungs. The hum beneath the Martian ice was never alien, it was familiar. The same echo lives inside every living cell, the small oscillations that keep blood flowing, thoughts firing, hearts beating. Mars only reminded you of it. Let that idea settle like warm sand through your mind. Nothing in the cosmos truly stops. Even after endings, vibrations continue fainter, slower, but still there. Death, decay, sleep, they're not silence. They're lower octaves of the same song. Imagine that hum, now expanding outward, merging with the one inside you. The sound of patience, of endless time, measured not in noise but in steady being. You can almost feel it in your chest, a pulse that belongs both to you and to the stars. The lights of the ship dim automatically, and the screen showing Mars fades to black. You don't need to see it anymore. You've learned what it had to teach, that peace isn't the absence of movement, but the synchronization of everything that moves. In a few moments, you'll drift to sleep. The hum will still be there, not as sound, but as rhythm, the steady reassurance that the world, all worlds, continue their gentle work even when you close your eyes. Let the pulse slow you. Let the quiet hold you. Let the planet far below keep time while you rest. Because that's all existence ever was, a shared vibration from red dust to soft breath, from distant orbit to warm heartbeat. And as you exhale one last time, the frequencies merge your pulse, the planet's hum, the universe's low murmur, until there's no boundary at all. Just resonance. Just rest. Just the sound of everything being okay.